Welcome to this comprehensive SQL tutorial course designed for beginners and also those looking to prepare for technical interviews. This course was developed by the team at Jovian, who have created many popular courses for our channel. In this course, we'll cover the basics of relational databases and SQL, including setting up MySQL, inserting data, and working with aggregation, grouping, and pagination in SQL queries. The course also covers advanced topics, such as combining tables using joins, executing SQL queries using Python and SQL Alchemy, and solving technical interview questions. By the end of the course, you'll have the knowledge and competence to excel in SQL.
Is it SQL or SQL? Well, it doesn't really matter, because you need to learn it no matter what it's called. Hello and welcome to this tutorial on SQL, where you will learn the basics of the structured query language, which is used to fetch data from almost every database in the world. No matter what you're doing in data science, you will need to learn these skills, and this will be part of your daily job. And this course guides you step by step, and you can follow along with everything that we do in this course to learn the basics of SQL and even learn how to crack interview questions from the top companies in the world. So I hope you enjoyed this course. Leave a comment and subscribe to our channel if you'd like to join more of these courses, and let's get started.
The topic for today is relational databases and the structured query language, or SQL. And here's what we're going to talk about today. First, we will talk about some of the use cases and the design of relational databases and SQL, what they are and why they are used. We will see how to set up a database locally using the MySQL server. We will create, modify, and delete databases and database tables. We'll see how to do that. We learn about the data types in SQL and some constraints like primary key, foreign key, etc. We will look at CRUD operations. You will see this term a lot in relation to databases. So create, read, update, and delete operations on data stored in tables. And then we'll also look at how data can be exported and imported from relational databases. This is part 1 of 2 lessons on SQL. So the next week will be an advanced lesson where we will look at aggregations, we look at joins, we look at indexes, and we will also see how to use Jupyter to get data out of a SQL database and how to work with it in Python. So maybe how to do some analysis and how to do some visualization. But today we are going to work in a more traditional setting where we are going to use some commonly used software like a MySQL server for working with SQL databases. Now, we learn about relational databases and SQL by working through this problem. This is a hypothetical scenario that we've set up, and we'll try and understand in the context of this problem why we want to use a relational database and how SQL is helpful. So Classic Models Incorporated is a manufacturer of small-scale models of cars, motorcycles, planes, ships, trains, etc. And products manufactured by Classic Models are sold in toy and gift stores around the world. So this is what some of their products look like. They are small-scale models of various types of vehicles. And Classic Models has offices around the world with dozens of employees. And these are primarily sales offices. So the customers of Classic Models are typically toy or gift stores. And each customer typically has a designated sales representative in the same region who's also an employee of Classic Models. And they interact with that sales representative directly. Then customers typically place orders requesting several products in different quantities, and then they pay for multiple orders at once via checks. So this is typically how a business works. You manufacture some products, and then you have offices, and then you sell your products to people, and you have transactions with them, and you have employees involved who are involved in managing these relationships and managing the offices that you run, right? Now, for an international organization like this, it is important to record all of this information, all of the activities in a single central place, right? So your task is to create a database, some sort of a system where you can record and manage all of this above information. So where do we have our offices, who works at these different offices, who are our customers, who is the sales representative for every customer, what kind of orders a customer placing, and what are the payments from them, what do the payments from them look like. So we want to record and manage all of this information in a database in a central location. And this database will also be used for day-to-day operations. For example, adding new customers, placing orders, recording payments, hiring employees, and things like that. And also just querying information and getting analytics about how the business is doing. So while there are many ways of storing data on a computer, for example, we could put this into a bunch of text files. We could maybe open Notepad, create a few files, and put in all this information there. But looking it up is going to be very difficult. We could use JSON files. We could use CSV files. We could maybe have a CSV file for customers, one for products, one for employees. We could use spreadsheets, things like Excel, which a lot of businesses use. But spreadsheets become a bit limited in functionality as you deal with really large data sets, and as you want to do some advanced forms of querying, and also as you want to integrate this with these systems with other systems. For example, you want to create forms for customers to sign up, you want to create order forms, you want to create a bunch of different things. Connecting forms with spreadsheets and writing custom business logic can be a bit tricky. So this is where a relational database comes into picture. A relational database is a data storage system, typically which has the following properties. So the first thing about a relational database is that data is stored in tables. So each kind of entity that we are concerned with, you have a table for it. For example, you have a table for customers, and this is a snapshot of some data stored in a relational database. So you have a table for customers, and each customer has a customer ID. They have a first name, they have a last name, they have a date created, which means the date at which, or the exact time at which that customer was added to your database. And then you have a bunch of information, maybe where they live, etc., right? So that's one important piece, that data is stored in tables. Second, each table has a set of columns. As you can see here, each table has a set of columns, and each column is used to store a specific type of data. For example, customer ID is going to be a number, and it's in fact going to be a unique identifier for the customer. First name and last name is their first and last name, and then date created is going to store the date or the time, exact time when they joined, and so on. Next, data in the tables is stored as rows. So each row of this data after this header row represents a customer. And sometimes these rows are also called records. So data is stored using rows within database tables. Next, tables support CRUD operations on rows, which means create, read, update, and delete. So you can add new rows into the table. That's the create operation. You can delete rows from the table. That is the delete operation. You can get data out of the table. Let's say you want to figure out which customers you have in the United States. Then you can query that. You can just type out some code and you will get back that information. And you can update information, because if a customer changes their address or their phone number or their email, you should be able to change that. Then one important piece, so a lot of databases support this, but one important piece is relations between tables. So tables can be connected to other tables using relationship constraints. For example, you have offices and you have employees. We can say in the employees table that an employee works at a particular office. So we can make a relationship between an employee record and an office record. And there can be one-to-one relationships. There can be one-to-many, many-to-one relationships. And we'll talk about these in more detail when we talk about joins. But at the moment, just the fact that you can link records across tables is an important piece to understand. Then relational databases typically allow you to retrieve data from the database using the structured query language, or SQL, which is what we will learn today. And these databases can either be hosted locally on your computer, or more commonly, these are hosted somewhere on the cloud for distributed access. For example, for classic models, it's possible that they have set up a database on the cloud and all the employees from all the different offices use this database through some browser-based application. Maybe they have forms, maybe they have some kind of access-based system where different employees have different permissions and they use this database, but everybody's ultimately making changes or getting information out of the same database, right? And this is how most modern applications work. For example, on Jovian, we have a relational database sitting somewhere on the cloud, and all of your account information is in the relational database. And when you open your profile, we get data out of that relational database and we show it to you. Okay. So that's relational databases. The important pieces are that data stored in tables, a set of columns, each column has a specific type, and then tables can be connected using relationships, and the data is queried using SQL or the structured query language. Now, when you are setting up a relational database, which you most likely won't have to do, because in most cases, whatever corporation you work with or whatever client you work with in a project, they will already have a database. But when you're setting up a database, it is common to first create an entity relationship diagram, or it's called an ERD, to describe all the tables within the database and the relations between them. So ERD, this is what an ERD looks like, an entity relationship diagram, and they can be created using drawing tools like Lucidchart. So typically this is something, an image like this is what you might be given when you join a company. They may give you an image like this and they would tell you that this is what our data model looks like, or this is what our database looks like. And sometimes you may have multiple ERDs because different teams or different orgs or different departments in the same company may have their own separate database, and sometimes you may have data duplicated across different databases and so on. But let's just take a look at this ERD and understand what it represents. So the first thing you will notice is we have these boxes. We have this one box called payments. We have this called offices. We have employees, customers, product lines, products, orders, and audit. So each box in an entity relationship diagram shows you a table. Okay, so for example, offices is a table. And then inside each box, this is the list of columns in the table. Now, the ERD does not contain any actual data. It is sort of a blueprint for the database on what tables it contains and what are the fields within each table and how the tables are connected. So the offices table, for example, will contain an office code, and you will see that this is, you can see a key icon here if I zoom in a little bit. So this is a key icon. So that is simply to indicate that the office code is a unique identifier for the office, and this is also called a primary key. So the office code is the unique identifier or the ID, just as on Jovian you have a unique ID which is your username. So similarly, office code is a unique ID. And then the office is based in a certain city, it has a certain phone number, it has a certain address line 1, address line 2, a state, country, postal code, territory, and maybe even a location, geolocation for plotting on a map. Okay. And different ways in which ERDs are created may or may not contain this additional information. For example, here what this blue square represents is that this is a required detail if it is filled in, and if it is not filled in, then that means that this is optional. So you can have address line 2 may not be present for some offices because it's enough to summarize the address in one line. But yeah, you may not always have these details. And this ERD does not contain information about the types of data. You can probably guess office code would probably be either a string or a number. A city would probably be a string. Phone would be a string. All of these would mostly be strings. Then you have employees. So for employees, we have an employee number. So that's the primary key. And I think that is going to be a number. Then there is a last name, first name, extension. So this is probably employees work at an office. So at the office, what is the extension to reach this person via phone? You have an email for the employee. And interestingly, there is this reports to field. So most employees in most companies report to other employees of the company. So this reports to is some sort of a link from employees to the same table of employees. So reports 2 would probably contain an employee number of another employee in the company. Then you have job title, and then you have something called office code. So office code again is going to be the office code of the office where the employee works. So you can already start to see these relationships. Employees work at an office, so there is an office code in employee, and that office code should match with the office code of a particular office. And then you can do interesting things like find all the employees who work at a particular office, or maybe given an employee, find the full phone number, which is the phone number of the office, combined with the extension for this employee. And similarly, you will now see other relationships. You have customers. So customers have all this information. And then in customers, you have the sales rep employee number. So this is going to be a reference from the customers table to the employee table. The employee number should match up with an existing employee. Then you have payments done by customers. So customers pay by check. So you can see here there's a customer number, which is a reference field. Then customers place orders. So there is a table where we are recording orders, where we have an order number, order date, some information about the order, some comments, and there is a customer number indicating which customer has placed the order. But of course, an order can contain a lot of information. So you can have many products that you would have, that you can include in an order. So we have a table for products, like product code, product name. Product code is the unique ID, product name, product vendor, etc. And product code, there is also a product line, which itself is another table. So you may have 4 or 5 product lines, and in each product line, let's say the product lines are cars, motorcycles, ships, etc. Remember, this company creates small scale models of vehicles. So product lines could be the different kinds of vehicles, and the products could be then individual vehicles or individual actual products that they create. And then there is this order details. So an order can potentially have many products that were ordered. So in order details, so for one order, you may have several records in order details. And you may have the order number, you may have the product code, and then you may have the quantity ordered. So let's say in order number 1, the customer number 10 creates order number 1, and in order number 1, they request product number 5, product number 6, product number 7, and each with a different quantity. So order details is used to track all that information. Okay. So this is how all of this fits together. You have tables with columns, and then you have relationships between tables. And understanding an entity relationship diagram is the first step towards understanding what a database contains. And all these symbols have certain meaning, which we will talk about the next time when we talk about joins and one-to-many and many-to-one relationships. Okay. Now there are several relational database software packages, and some of them are free and some of them are open source, while others are paid and proprietary. And the most common ones are these. MySQL is an open source and free option. They also have a paid option, but the free option does the job for most people. Then you have Postgres, you have SQLite, you have Microsoft SQL Server, MariaDB, Oracle, IBM DB2. So some of these are proprietary. So for this tutorial, we will use MySQL, a free and open source relational database software. Now, the concepts that we learned today will be applicable across any of these, but the syntax, the actual code that you need to write may differ. So just keep that in mind and just try to understand the key concepts. And we'll talk about how you can look up the differences in code. Maybe by comparing, let's say, with the Postgres database. And primarily, it's simply a matter of looking it up on the documentation or finding a Stack Overflow answer. Over time, once you join a company, most companies will only use one type of database. So over time, you will become comfortable in the flavor or in the kind of in the software package that your company uses and the variations in SQL in the SQL language that software package requires. But your skills should be transferable across different SQL variants. Okay, so we've been saying SQL a lot, or SQL. what is it? So SQL stands for Structured Query Language, and it is a programming language for interacting with relational databases. Now, we've set up this database somewhere, and now we need to put data into it, and then we need to get data out of it. Maybe we need to change some data within it. For doing all of those things, you use the SQL programming language. And unlike general purpose programming languages like Python, Java, C++, etc., SQL has a very limited syntax and a very specific use case. The specific use case is to interact with a relational database. You cannot use SQL for data visualization. For example, you cannot use SQL for building software, building web applications. You cannot use SQL for creating scripts. You cannot use SQL for machine learning. That is not the purpose of SQL. The purpose of SQL is to put data into tables, into relational database tables, and get data out of relational database tables and make changes. So it's all about working with a database. Without a database, there is no SQL. And this is what its syntax looks like. So this is all one single SQL statement. It's split across multiple lines, but you will see at the end there is a semicolon indicating the end. So here what we're saying, and SQL is a very readable language. So here what we're saying is select top 3. So we want to select the top 3 products. So we want to select product ID from the sales table, and you want to select the product name, and you want to select the total quantity of products sold from the table sales, and then you want to do a join. So again, there is some joining, merging involved, and then you're doing some kind of a grouping, and then you're doing some kind of an order by, and then you're doing some kind of a sum, and then you are sorting it in descending order. So you have all of these things that you're putting together. There are many pieces that are coming together here, and we will learn some of these pieces this week and some of these pieces next week. But by the end of these 2 weeks, you will be able to understand exactly what this statement does, and you will be able to write statements like it. And it's not too difficult. It's just that you have to understand what each of these parts represents. Okay. And that's what we will go over step by step. So you type in a SQL query and you send it to the database, and then the database gives you a result. So typically it is some sort of a subset of the table. Like here we are selecting a certain set of rows, so the database has given just 3 rows of data, and it has given just 3 columns of data. The actual table or tables that this information has been drawn from can contain several thousands or millions of rows and can contain several columns as well. So you don't always want to see all the data. Sometimes you just want to see the data that you are concerned with, and sometimes you also want to summarize data by taking the sum, etc. Okay. Now, a quick note on SQL statements. There are 3 types of statements in SQL. One is called the data definition language. So there are 3 parts to setting up a database. First, or using a database. First is to set it up, which means taking the entity relationship diagram and converting it into an actual database with actual tables in your local copy of the software or somewhere in the cloud. Okay, so here we are concerned with generating a table, generating a database, or modifying the structure of a table, making connections between tables. That is called the data definition language, or that is one of the parts of SQL. Then you have the data control language. The control language is primarily about managing user access rights. So for any database system, you have a way to assign permissions to users. So you can create users and then you can give users permissions, and some users may have read permissions, some users may have write permissions. Sometimes you can also control information per table. So you can control who can write to, let's say, the employees table. So only the administrator should be able to create new employees, but maybe all employees should be allowed to create new customers, right? So you have all these rules, and that is also something that you can do with SQL. Not something that we will cover extensively, because this is not something that you will have to deal with. Maybe the database administrator will already set this up for you. But the most important thing that we will deal with is the data manipulation language, which talks about which is the most frequently used subset of SQL, and it is used for searching data. So if you have a database, getting some data out, inserting data into a database, updating a database, updating some information that's already there, and deleting data, right? So The CRUD operations, create, read, update, and delete. Those are the operations covered in the data manipulation language. Now, you don't need to really worry about these terms, DDL, DCL, DML. You never have to deal with them. But it's just that you have there are three ways in which we use SQL statements: to create a databases and set up the structure, to manage permissions, and most importantly, to actually do CRUD operations on the data. And before we start writing some SQL code, a quick note on the syntax. So SQL syntax is case insensitive, which means that you can type statements in uppercase, lowercase, or a mixture of both. Like here we have select top 3 sales.product ID. You can write select in lowercase. You can maybe write S as a S in lowercase and E in uppercase, L in lowercase. It won't matter. Same is true with all the column names. Most of the time in most SQL distributions, they are case invariant. So you can use uppercase, lowercase, whatever seems more convenient to you. Okay. And one thing that you will notice is at certain places, we will use these backticks or backquotes. So this is called a backquote, especially for database names and column names and table names. Now, these are optional. So wherever you see this character, it is completely optional. The reason it's there is primarily just to differentiate between the SQL syntax and keywords and actual table names and such. Okay, and we'll see this in just a moment. Then SQL statements can span over multiple lines. So you can write 3, 4, 5, 10 lines in a SQL statement, and you have to end it with a semicolon. That's the important piece. If you don't put in a semicolon, then your statement may not get executed, or the system may still keep waiting for some output. And then finally, all the statements that we are going to execute in today's tutorial can be executed on MySQL. Now, this MySQL can be running on your computer, it can be running somewhere on the server, and it can be accessed in 2 ways, which is the command line or the workbench. And we'll look at both in just a moment. Okay. Now the SQL syntax, as I mentioned, for every relational database software package is slightly different. So if you're using Postgres or you're using Microsoft SQL Server or Oracle, it's going to be slightly different. So just check the official documentation of your database for details. What we will learn is the kind of operations that you can do on database tables, and the specific syntax is just a matter of looking it up. All right. So with that, let us set up MySQL Server locally. Now you don't need to do this right now, but whenever you're following along with this notebook, definitely set it up locally on your computer. And the download takes a while. That's why I'm recommending you don't do it right now, but do set it up locally on your computer and experiment with all of this code, all of the things that we are doing to see the effect that these statements have. Okay. So you can download, you need 2 things. You need to set up the MySQL server. So here's the MySQL server. You can go to dev.mysql.com/download/MySQL and select your operating system. In my case, it's Mac OS, and then select the kind of archive you want to download. You can see that this is a 415 MB file, so it takes a while to download. Now I've already done the download, so I don't need to do this again. But if you're on Linux, for instance, then you may want to either download a tar archive, or if you do download a tar archive, then you may have to follow some additional instructions as well. If you're on Windows, I think you should be able to download download a zip archive that you can directly open up an exe on. I think on Ubuntu, you should be able to download some kind of installable bundle. So whatever operating system you're using, you should be able to download one version. Now we just need the MySQL server. We don't need anything more than that. And the MySQL server will set up a database for us and allow us to create tables within databases and query databases and so on. And you can run it, and we are going to run it locally, but it can just as well be hosted on a server as well, right? But we are going to run it locally. To interact with the MySQL server, one way is to use the command line interface. So now in my case, I have installed it on Mac. So I'm just going to open up a terminal. And let me zoom in this terminal a little bit. Yeah, so now I have opened up a terminal. And when I installed MySQL after downloading, it created this folder /usr/local/mysql. So it created this folder, and you can see this folder here if I do ls. And where did I find this? Well, I just looked it up. Where does MySQL get installed on macOS? And I got this response that it's in /usr/local/mysql. In your case, in your operating system, this location may be different. This may be in C program files, or this may be in somewhere else on Ubuntu. So you would have to look this up. But in this folder, /user/local/mysql, there is a folder called bin. So I'm just going to type /bin here. And then there is a folder called, let me just check ls on bin. So you have a lot of things inside bin. But the one we should be concerned with is MySQL, the command line interface. So I'm just going to run /user/local/bin/mysql. So now this is a command line tool that I'm going to run. Okay. And to run this, the first thing that you will need to do is you will need to provide a username. And by default, when you install MySQL, it will have the username root. And then you also need to provide a password when you're installing. So when you download this file, and then you're going through the installation steps, it will ask you to set a root username and a root password. In my case, I set my root username to root. That was the default option. And I did set a password as well. So here is how you specify the username and the password. So you say, you give the path to the MySQL binary or the MySQL command line tool, and you specify using -u, which user is trying to access it, and root was the default user that it had set up. And you specify -p, and it will prompt you for a password. So I'm just going to type in the password here. Yeah. So I've just typed in the password now. And now what has happened is MySQL was already running on my computer after I installed it. But now I have logged into this database server, which is running on my computer as the user root. Okay. And if MySQL is not already running on your computer, then you will not be able to log in. So if you get an error here that MySQL is not running, then you would have to go and check. In my case, what happens is on Mac OS, so on Mac OS, it creates this MySQL option in settings. So if I go to my system preferences, it creates this option MySQL. And here I can actually stop and start my server. Here I can also just set up some configuration about where MySQL is going to store all of its data, right? So by default, MySQL will start up whenever my computer starts up. So I can set all these configurations, right? So the MySQL is a application that is always running on my computer, and it starts up when the computer starts up, it shuts down when the computer shuts down. You will have to set it up separately on Linux or on Windows. And when you do install it, normally all of this should be taken care of automatically. Okay. So make sure that MySQL server is running, and find the path to this MySQL binary, which is on Ubuntu also. I think it's user local MySQL bin MySQL. On Windows, it might be slightly different. And then log in into MySQL. So log in into the server as the root user. And once you've logged in into the root user, you will see a welcome message, and you will see the version of the MySQL server that's running on my computer. And now I can start interacting with it on this prompt. So as you see here, it says MySQL, and then I can start typing SQL commands here. Okay, so that's one way to interact with this database. And I am currently running on my local machine, but if there was a MySQL server that was running somewhere on the cloud, and I had the URL to that server, so I could also put in the URL. There's a way to specify the URL when running this tool. And you can use this tool to connect to any MySQL database anywhere in the world, as long as it is publicly accessible and you know the username and password for it. Okay, so if you have the URL to a MySQL server, you can log in into that MySQL server as well. Like for example, I from my computer can log in into the Jovian production MySQL server and maybe make changes to my username and things like that. Okay. Alright, so that is one way to access MySQL. That is one way we will look at today. But another way to access MySQL is using the MySQL Workbench. So there is another installation link that we've included here. This is to download the Workbench, which is basically this graphical user interface. So you can download the Workbench. This is again a 100 MB download. And the Workbench also, let me open it up. The Workbench also connects to a MySQL server. So when you log in for the first time, you will see that it automatically detects that you have a MySQL server running locally. But if you want, you can also connect to something that is running somewhere on the cloud. So again, if you have the IP address, or if you have the host name, if you have what port it is running at, if you have the username and password for a database server running on the cloud, then you can get those details and connect to that database. So typically in a company setting, what will happen is the team that you're working with, or the person that you're reporting to will tell you that here is where our database lives. So you should set this IP for our database. You should set this port. You should use this username. We have created a username for you. You should set this password. And then you can click connect, or you can even test the connection first, and then you can click connect. And then you will automatically get connected to the company database. And then you can work on the company database or your team's database and get data out of it, or write data into it, do queries on it. In our case today, we are going to just use the local installation that we have of MySQL. So I'm just going to connect MySQL Workbench to the local installation. All right, so this is what it looks like. And the kind of queries that you type here, for example, I can type a query. So for example, I can type a query here on the MySQL command line tool, show databases. And I can type the same query here in the MySQL Workbench, show databases. And then I can run it. So this is the way to run it. Or you can also press Control Enter or Command Enter to run it. And it shows the same information. So here it shows the information classic models, information schema, MySQL performance schema, etc. And here it shows the same information as a table. Okay, so it's just a little nicer. Here everything is shown as text. Here you can interact with it a little bit. You can click on things and such. So they are just two different ways of interacting with the same underlying database that's running locally right now. And both of these can also connect to things on the cloud. Okay, so with that out of the way, we can finally start working with databases. So let us set up a database for classic models. In my case, I have already set up a database. So let me just remove that database for now. Okay, all right. So once you are connected, either through the command line or using the MySQL Workbench to a SQL server, so the server could be running locally or on the cloud, you can start writing SQL statements. So the first thing that you want to do as soon as you're connected to a database server is to just list the databases that are present on the server. So I can just type show databases and put a semicolon, and that is going to show me the list of databases that are present on the server. So by default, right now I've just set up this MySQL server on my computer. So these are all some of the default databases that MySQL already has. So we definitely don't want to disturb any of these, which is information schema, MySQL performance schema, and sys. Okay, but once you create more databases, you will start to see those databases showing up here. So that's the first thing. Show database is going to show you a list of databases. Then the next thing you can do is you can create databases. So here is how you create a database. You type create database and then you type the database name. So I'm going to create a database classic models, and let me just run the statement. So I've typed create, I've typed database, and I've typed the name of the database, classic models. And now the database is created, and I can check show databases once again. And now you see you have classic models here as a new database that has been created. Now, in this notebook, what you will see is the statements are typed in uppercase, create database is uppercase. And one other thing you will notice is that all database names, column names, table names, all of these are lowercase and they are indicated with these backticks. This is called a backtick. This is just for visual separation so that you know that this is a SQL keyword and this is the name of a column or a database or a table. So this is just for that visual separation so that when you're going through this notebook, it's clear to you. And you can also run it like this. You can take this code and you can run it exactly the same way as it is typed here, or you can type it without any of the backticks and just in lowercase. And this is also perfectly fine, except that it's a bit difficult to read. Okay. So now that we've created the database, we can now show the database as well. Great. And if we try to create it again, MySQL will give us an error. So you can see here, we run create database classic models and it says it can't create a database because the database already exists. So we can also specify a condition to create the database only if it doesn't already exist. So if we say create database if not exists classic models. So this is when we don't know if there's already a database with that name on our server. So then we can create that database if it does not exist. If it does exist, then nothing happens. So if we type this create database if not exists, you can see that it says query okay, one row affected, but there was no real change. Like if we say just show databases, you can see that we have classic models, information schema, MySQL, performance schema, and sys. So no change here. On the other hand, if we had typed create database if not exists classic models 2, and by the way, I'm using the up arrow key to cycle back to older commands. So up and down is how you cycle between older and newer commands. So if I type create database if not exists classic models 2, you will see now that we have classic models and classic models 2, which got created. Okay. So now we have several databases on our server, and typically for every project that you're working on, you would create a database, or sometimes every team would have a database on the database server. So there are many different reasons for why you may want to have different databases. But for classic models, the company, we're just going to create this one database. Okay. And when you are connected on a server and you want to work with a certain database, let's say you want to get data out of the database, you want to add tables, remove tables, add rows, remove rows, you have to tell which database you want to use. So we can say use classic models. And once you say that, then MySQL is going to change the database to is going to point to classic models as the default database to which all operations will be applied. So let's say now if we do something like a create table operation, which we'll see now, and then we type the name of a table and the columns that it has, then that table will get created inside the classic models database. Okay, so whenever you get started, always make sure that you are running the use statement to select the database that you want to operate on. Typically MySQL remembers this, so you won't have to do it over and over. But whenever you log in, it's always a good idea to just run use classic models. All right, so that's how you use a database. And one last thing I want to cover is how to delete a database. To delete a database, you just type drop. So we have currently classic models 2, information schema, etc. So I'm just going to do drop database classic models 2 and a semicolon. And now if we check show databases, you can see now we no longer have classic models 2. That database was deleted. I can also go ahead and drop classic models, and then you will see that now we no longer have classic models either. Okay. Now be careful about drop, because as soon as you run the drop statement, the data will be deleted permanently. There is no trash and there is no warning. There is no confirmation. And typically your company will not give you access to drop databases for good reason. But regardless, you should be very, very careful about running the drop database command. Okay. So as an exercise, you can now just try creating, deleting, using some databases, using the commands that we've covered, and also try and figure out how to rename a database. So now you can try and look it up on the MySQL documentation or just by searching online, how to rename a database. Okay. Next, just before we move forward, let's just recreate the database classic models because we are now going to create some tables with it. So I'm just going to run create database if not exists classic models and use classic models. All right. So now our database is created and we can start using it. Okay. Let's now talk about how we can work with tables. Now, we remember the entity relationship diagram that we created for the classic models company. We can now start adding some tables based on the ERD. And there are a few statements, there are 4 or 5 statements that we need to understand to work with tables. The first one is to list the tables in a database. Now, once you select a database using the use command, you can list the tables in a database using the show table statement. So if we go here and we say use classic models, and then we say show tables, you can see that currently it says empty set because we've just created the classic models database, so it does not have any tables. But we know that it is empty, so we know that much. Then to create a table, we can use the create table statement. And here's what the create table statement looks like. You type create table and then you type the name of the table. And then you have this, you open these brackets or these parentheses, and then you type the name of a column and then you type the data type of the column. And then below it, you also have some constraints about the tables or some other information that you want to specify about the table. So I just want to show you an example of what a create table statement looks like. So here is the ERD diagram for the offices table. Now for the offices table, we have this office code, which is the unique identifier for each office, or this is also called the primary key in SQL. Then we have all this information, city, phone number, address line 1, this is all required. And then we have address line 2, state, this is optional information. Then we have country, postal code, territory, this is required. And then we have office location, which is optional. So this is what the create table statement for offices looks like. So we say create table offices, and again, you can skip these backticks. These are just for convenience. Sometimes column names can have spaces. So to handle things like spaces, we have backticks, but here you can just use it to visually identify what is a SQL statement and what is a name of a database or a column or a table. So we say create table and then we type create table with the name offices, and then we open up this bracket and we say office code. So that is the name of the first column, and office code is going to be a varchar. So this is the data type, and we'll talk about the data types. And so it is going to be a character list or a variable number of characters. That's what it means, varchar, of up to size 10. So office code can be one character, 2 character, 3 character, up to 10 characters. Then we are specifying here a constraint that it is not null, which means that it cannot be empty. Then we have city again, which is a varchar 50. So it can be a string. Varchar simply corresponds to a string essentially. It can be a string up to 50 characters long. Again, not null. Then it will have a phone number. Again, it will be a string, not null. It will have an address line. It will have a second address line, and this time this can be null. So we don't necessarily need to have a second address line. It can have a state. Again, this information can be null. It can have a country. This should be not null. A postal code, a territory. Okay. So territory would typically be, I think it would probably be country or maybe the territory which the office operates in. Okay. So we'll see an example of this. And finally, at the end of specifying all the columns, we are also specifying this constraint or this additional piece of information that we want office code to be the primary key for this column. So what this does is the primary key constraint uniquely identifies each record in the table. So the office code value in the office code column will uniquely identify each office. And what that means is that you can only have one row with a specific office code. You cannot have 2 offices or 2 rows of data with the same office code, and it also cannot be null. And that's why we have specified not null here already. Okay. And a table can have only one primary key constraint. So you can select multiple columns. You can say that the primary key is office code, comma, city. Although in this case, it will not make sense. Sometimes it does. So you can select multiple columns as the primary key. So a primary key can consist of multiple columns, but you should only have the statement written once. So if you want to select office code, comma, city, so both of those together as the primary key, then you should write primary key office code, comma, city, and not primary key office code and another line primary key city. Okay. That's a more special case that doesn't really happen. So for now, let's just take this code and let us run it here in our MySQL command line. Okay. And we run it. And as soon as we run it, it says query OK, 0 rows affected. So whenever you see OK, that means that it has had the intended effect. So now if we run show tables again, you will see now that there is one table in classic models. The table is called offices. Okay. Now talking about the data types, you see varchar, most of these are varchar, but there are several supported data types in SQL. So here are some of them. You can have numeric data. So you can specify that a column is a bit. Bit means it's going to be a 0 or a 1, or a tiny integer. I think that is going to be 1 byte, which means it can take values from 0 to 64. A small integer, I think that would be 4 bytes. A normal integer, I think that would be, a small integer would be 2 bytes. A normal integer would be 4 bytes. A big integer would be 8 bytes, etc. So the differences between all of this is simply in the range of values that they can hold. Bit can only hold 0 to 1. Big int can probably hold from minus 2 billion to 2 billion. So depending on what range you think that your numbers can take, you can choose the right data type. And if you're unsure, just go with int or big int, just to be safe. A lot of companies have had to change from int to big int once they hit maybe a billion users. So not many such companies, but that was a real problem. They probably didn't expect to hit a billion users, and they had to change from int to big int for user IDs, numeric user IDs. Then you have the decimal data type. So if you're sure about how many digits of decimal you want, then you can use the decimal data type as well. Or you can also use a numeric data type. I think this allows you to put in any kind of data, something that you would have to look up. You can use the float data type to work with floating point numbers. Here you can specify how many digits of precision you want. And then you have the real data type as well. So again, not all of these data types are supported by all SQL software, because all companies have implemented their own version and they have their own optimizations. So you would have to look up whichever package you're using. Like for MySQL, you would have to look up which of these numeric types MySQL supports. And then there are date related types. So you typically have a date, time, and then a date time or a timestamp data type for working with dates. Then you have the character types. So you can have a character, which is a single character, or you can also specify when creating a char data type, what is going to be the exact length. So if you are sure that you will always have 5 characters in a column, you use char or char 5. So just as we have written varchar 50, you can write char 5, and then you always have to put in 5 characters. Or you can put in varchar, and varchar means that you can put up to 50 characters. So if you type varchar 50, that means you can put up to 50 characters. And then you have the text data type, which is typically used for very large strings. So if you want unbounded, if you don't want a limit on the number of characters, then you can use the text data type. Now, what is the benefit of not using text, maybe using varchar? It is efficiency. When you can specify the number of characters your data can take, based on that, the database server can perform some optimizations to make queries faster. But if you want to use the text data type, then you are giving up on some performance. Then you have these Unicode characters, which is just a special case of characters. You can also store some binary data, and then you can also store something called a blob, which is like a large binary object. So you can store XML, JSON, and these are more specialized types that are not supported by all SQL servers, but numeric, date, and characters or strings are the most common data types. Okay. So that was data types. And next, once a table is created, you can also check, once a table is created, you can also check the table that the table is created using show tables. Here we've typed show tables and we were able to see the table. And if you want to get information about what columns the table contains, you can use the describe command. So let's type describe and let's type the name of the table. The name of the table is offices. And when you type describe offices, you can see here, these are all the fields: office code, city, phone, address line, state, country, postal code, territory. All of these are varchar. Some of these are nullable, which means some of these can be null and some of these should not be null. And office code is a primary key. Okay, so this is still information about the table. This is not information in the table. It's just information about all the columns of the table. And you can also specify default values for some of these columns. Let's say you want to specify a default value of phone number to the phone number of the headquarters, so that there is always a number listed on your website. So you could have specified that. The way to specify a default is to say, let's say phone number not null, and you could instead say here phone number default, and then you can give the phone number that you want to have as the default phone number. Okay, maybe +1. That's the default phone number. So that will be the default phone number that will be put in for any row in the data. Okay, so now we've created a table. We have seen what its fields look like. We have seen that that table got created. Let's put some actual data into the table. So to insert data into the table, we use the insert into statement. So here's how the insert into statement works. You type insert into, and then you type the name of the table. So the name of the table is offices. And then you type the columns, the names of the columns that you want to specify. So I want to provide the office code. I want to provide the city. I want to provide the phone. I want to provide the address line 1. And maybe I won't provide address line 2 because I don't have that information. I am not going to provide state. I'm going to provide country. I'm going to provide postal code, and I'm going to provide territory. Okay. So we say insert into offices, and then we give the list of the column names that we are going to supply. And then we say values, and then we provide the values for these column names. So, okay. Now I'm going to create this new office with the office code AAA, and it is going to be in Bengaluru, and the phone number is going to be +91 that, and then the address line is just going to be, well, let's just put it as 1 MG Road, and then we have a postal code. Let's just put that as 56001. Oh, we also have to specify the country. So the country is India. And then finally, let us put in a territory here. So I guess that this will probably serve the territory of Asia. Right. So let's then put the semicolon here. So what have we done? Insert into, name of the table, list of the columns that we want to supply information for, put in, then type values, then give a list of the actual values for each of these columns, and then we can hit enter, and you can see query OK, 1 row affected, and now this is going to insert the data into the table. How do you get data out of a table? Well, the way you get data out of a table is by typing select. You can type select, and then after typing select, you type which columns you want. So let's say I just want to get the office code, and I want to get the city from the name of the table. The table name is offices, and then I put in a semicolon. Yeah, sorry, no brackets here. So you type select, and then you type the name of the columns that you want to select, and then you say from offices. Okay. And you can see that it starts to get a little bit confusing now because everything is written in lowercase, and that's why we often write the column names in lowercase and we write the SQL commands in uppercase. Okay, and sometimes we also put backticks just to make it super clear. And especially if we have names if we have spaces in column names. Okay, so select office code comma city from offices. So now it is giving us the office code and it is giving us the city for all the rows of data in the database in the table offices. So we have inserted one row. We inserted a row with all this information and then we viewed it using select. Now, if we had inserted multiple rows, we would be looking at the data for multiple rows of data. How do you insert multiple rows? Inserting multiple rows is the same as inserting one row. You just say insert into offices and then names of columns and then type values. And then you give one set of values, then you give a comma and you give the second set of values and so on. So let's insert multiple rows. I'm going to copy insert into offices and then I have a bunch of rows of data here. So I'm going to copy all those rows of data. Okay, it's going to be a bit difficult to copy this. All right, let's just copy it this way. Now this is a lot of code there. So I am going to, instead of using the MySQL command line, which I can do, I can just paste on the command line here. I'm just going to show it to you on the workbench. Okay, so I'm just going to type it here into the workbench. You can always just click new query and you can just always click this new query here and then just type it. So here now we have insert into offices. We have all these columns that we want to insert and then the values we have one set of values, two set of values, 3, 4, 5, 6, all the way up to 7. So we are inserting 7 values and at the end you will notice a semicolon here at the end of the last statement. And we can run this command and now we get a success result here. Oh, we need to select a database first. So let me cut this and let me say use classic models and let me run that. So that has been selected, the database is selected. Then let us paste it back. Okay. Now we have insert into offices and now we run insert into offices and you can see that it executed successfully. So now we have inserted into offices and I can create a new query here. So I can now remove this and I can type select. And if I want all the columns, I just type star. So select star from offices. And then I run it and that is going to now show this data in this tabular format. Okay, so now you can see that we have all these offices: San Francisco, Boston, NYC, Paris, Tokyo, Sydney, London, Bengaluru. And this is the same information that we had shown, that we had inputted here, that is also available. So through the command line and through the workbench, we are connecting to the same database and we can run these commands in either place. And I can type it here as well, select star from offices. So now when I say star, it is going to select all the columns. And here's what that looks like. It's a bit messed up, the output, because it's trying to display it all on one line. But if I zoom out a little bit, you should be able to see the output. Yeah. So you can see the output now. When I do select star from offices, it is giving me the same table that I am able to see here on the workbench. Okay, so that is insert and select. Just a quick reminder on how these work. So you can say insert into and then provide the table name, provide the names of the columns you want to insert, provide the values and then provide lists of values to insert, so list of rows. And if you're providing data for all the columns, then you can skip this part, which is the column names. So you can just say insert into table name, values, and then you can give lists of values and that will work fine too. For example, here, when we are inserting offices, we are using all the columns here. So I can actually just completely skip this last thing. I can skip this names of columns and I can just say insert into offices values and give it the list of values. Then to view the data, the simplest way to view data is using the select statement. So it has the syntax select column 1, column 2, so on from table name. And you can also view the data from all the columns using simply saying select star from table name. Okay, so that's how we put data and get data. So now we've covered C and R, create and read. And we'll look at update and delete as well. And here are some exercises for you. Try adding some more entries into the offices table using just the required columns. So an example that we typed out on the MySQL command line, try typing it out yourself. Try doing it from the command line, try doing it from the workbench, and see what happens. See what happens if you don't provide a value for a column marked as not null. Okay, maybe here, if I go back to one of these, and if I try and change this, let's say I change the office code to AAB, and I don't provide a value for territory, which is supposed to be non-null. Let's see what it's going to give us. So it's going to give us an error, but you want to make these mistakes, and you want to understand what kind of errors you get. Like here it says field territory doesn't have a default value. So look through it and try to break things and try to become familiar with errors so that when you encounter them, you will be able to debug them more easily. Try adding an entry with a primary key matching an existing entry. So maybe let's try that. Let's try putting in AAA again, and let's just make it Bengaluru 2. And let's just put in territory Asia here. And let's add back territory here. So you will now see that, okay, I probably have, yeah, there's probably a syntax error here. Okay, I made a syntax error here somewhere. But if I just try to insert the same data again, like AAA Bengaluru 2, you will see that now it says that there's a duplicate entry AAA for the key offices.primary, and that data is not inserted. Okay. So test these out. The more you try, the better you will understand how some of these things work. And try and retrieve and display just the city and phone number information for each office that has been created. So just do a select statement and try that out too. And that's the first table that we've created. We've put some data into the table. We have looked at the structure of the table, and we've retrieved some data from the table as well. Next is the employees table. So we've created one table, and now we are creating a second table, and we will connect this table to the first table. And a quick note, if you want to first delete a table, then you can use drop table. So if you type drop table, that will delete the table with all its data. Like if I type drop table and then I type offices here, that's going to delete the offices table. I don't want to do that right now because I've put some data into it. And you can also have something like this, that if the table exists, you can drop it. So if we type drop table if exists employees, this is not going to make any change, because if I do show tables, there was no employees table before and there's no employees table now. But whenever you're creating a table, you can always, it's a good idea to first maybe drop the previous table if you're sure that you don't need the old data, if you want a fresh table to be created. So you can just drop the previous table if you want, right? So that's why we have the statement here for you as well. So, okay, let's talk about creating the table employees. So let's copy this code. And here we have an employee number. So that's an integer, our first encounter with integer. And here we're saying 11. So I think what we are specifying here is, I think it might be 11 bytes or 11 digits. I'm not sure. I think it's going to be 11 bytes. I'd have to look it up. Then we have the last name, which is a varchar or a string. First name is a string. Extension, this is their phone number extension. So they will be at a certain office. And that's why we have office code here. And then we have an email, which is again a varchar of 100. And then we have a reports to. So two interesting things here. One is office code. So we have now an office code column, and this should ideally contain a value of a valid office code. How are we going to ensure that? We will see. And second, reports to, and this can be null. So office code should not be null. Every employee belongs to an office, but reports to can be null because obviously there will be somebody in the company who does not report to anybody. But otherwise, reports to, and maybe some people may not have been assigned a manager or a reporting person. So reports to can be null, but reports to should be somebody's employee number. Let's say you have Siddhant and Biraj, and if Biraj reports to Siddhant, then reports to in the entry for Biraj should be the employee code or the employee number of Siddharth. Okay. How do we ensure that? We'll look at that. Then we have the job title. This is just a simple string. And we are setting here that primary key is employee number. That makes sense. We want to uniquely identify each employee with a primary key. And this is going to be not null. So that's fine too. And then we have these two statements, foreign key. So here we are saying that reports to, the column reports to, references the table employees. And in the table employees, it references employee number. Okay, that's one. And then we have another foreign key, office code. So here we are saying that the column office code in this table references the column office code from the offices table. Okay, so there are two references here. One is a reference to another table. One is the reference to this table itself, but probably to a different record. So what we are saying through this, or through a foreign key in general, is that we want to ensure that the office code column contains a value which matches a value in the office code column from the office's database or from the office's table, right? So for every employee, there should be an office code, and that office code should contain a valid value from the office's table. And that is what the foreign key constraint ensures. And we will test it out in just a bit. And then similarly, we have foreign key within the same table. We want to say that the reports to for any employee should be a valid employee number from the employees table, and it can be the employee number of a different employee. So that is all enforced using a foreign key. A foreign key is simply you're saying that this number or this column has a special property that it refers to a value from another table. And there is one important constraint with foreign key. The value that you reference to must be the primary key in that table. So for example, here we are referencing office code of offices. So office code must be the primary key in the offices table. Now, again, this is not a criteria that all SQL software or all relational databases have. Sometimes they do, sometimes they don't. But in general, just to be safe, you should always assume that you should only reference primary keys. Okay. So let's try it out. Let us insert a value into employees. So let me just grab this. Insert into employees the values 1002. So that's the employee code. Murphy, Diane, X5800. And so this is, what is this? Employee number, last name, first name. So Diane Murphy 1002. And their extension is 5800. And their email is dmurphy@classicmodelcars.com. Then their office code is 1. And do we have an office code 1? We do have an office code 1. 1 is San Francisco. So that means they belong to the San Francisco office. Then reports to none. So they do not report to anybody. And in fact, Diane Murphy is the president. So they're the boss. So let's run it. Oh, it says employees doesn't exist. Oh, that's because I dropped the employees column. I never created it in the first place. All right. So let's first create the employees column. Create table employees. Let's take this and let us run it here. So now the employees column is created. And then let us insert some data into the employees column. I am just going to insert this one person right now. Diane Murphy. And that's it. And let me just put a semicolon here and insert the person. So now if I do select star from employees, you should be able to see, sorry about the formatting, but you should be able to see this information about this person. Diane Murphy with the employee number 1002 has the office code 1 and reports to nobody. Let's add another employee. Maybe let us set their, let us set their office code. Let's set their employee code to 1002. or 1003, and let's call it Daniel, and let's give an invalid office code here. Maybe let's give 100 and let's see what happens. So here you will see that it cannot add the child row. So this is called a child. So the employee is now called a child of office because it has a foreign key constraint, and the foreign key constraint fails. You can see that the foreign key constraint that this should be a valid office ID fails, and that's why you cannot add that row. Okay, and that's how the whole thing works. All right, so maybe let's add all these employees and then we will move forward. But to add all these employees, there are going to be some issues because I've already created an employee with the primary key 1002. So before that, I'm just going to delete the employee that I've just created. You see right now I have this one employee, Diane Murphy. So I want to delete the employee with employee number 102. So I can say this, I can say delete. Well, actually, let's come back to delete later. For now, I'm just going to drop the table entirely. So drop table employees. Okay, so now the table employees is gone. If I do show tables once again, and now I can create the table once again. I will go create table employees. And then let us insert all this data. So we have a bunch of employees here. I'm just going to copy all of this and paste this command. If you want to do the insertion here, so maybe let's just do the insertion here. So we're just going to insert all of these employees. How many are these? We are going to insert about 23 employees using the MySQL workbench, and now these should be created. So now if we check select star from employees, you should now be able to see all the employees that we've created. Okay, now here are some exercises for you. Try inserting an entry into employees with an invalid office code. You saw what happened, but try it maybe from the workbench. Try inserting an entry into employees with an invalid value for reports to. Okay, that is something that we haven't tried. So reports to can either be null or it must be an existing employee's ID or employee's number. And try creating a new office location first, and then try adding some employees to the new location. So when you open a new office, first you will have to add a new office object or a new office record, and then you will have to add a bunch of employees for those office records, and maybe you will have one office manager, and that office manager will probably report to the president, and then you will have a bunch of employees at that office and they will report to that office manager. Okay, do try out that exercise. Okay, moving ahead, now we have the customers table. So now by this point you're probably getting the idea. There is a primary key, there are a bunch of required columns, there are some optional columns, and then there is this foreign key. So every customer has a sales rep, optional sales rep. So you can take this foreign key, a sales rep employee number, and that should reference in the employees table some employee number. And you can see here that sales rep is an integer, but it can be null. So I can just copy paste this. I can take this, create table if not exist. So this is another way to go about it. Create a table only if it does not exist. All of these are slightly different. If you try to create a table without this, so if you just say create table customers, if there's already a table customers, it's going to fail. If you drop the table first, then it's going to delete all the data. If you say create table if not exist, then if the table exists, it won't do anything. If the table does not exist, it is going to then create the table. So think about what is the right thing you want to do. And based on that, use these drop and not exist and does exist and play around with them and see what they do. Okay. But I'm going to take this create table, put it into my workbench, and just execute it, and this should create another table. Yeah, this should create another table, customers. And on the left, if you just check the schemas tab, you should be able to see all the tables that are present. So now you see here, you may have to refresh it a couple of times, but you have this customers table, you have employees, and you have offices. And when you click on a table, you will also be able to see the information about that table. Like on customers, you have customer number, customer name, last name, first name. So this is how MySQL Workbench makes it a little easier for you. You don't have to type a lot of commands like describe and such. You can just browse the tables that are there. You can also browse the information about the tables. You can in fact even check values within the table. I believe if you just click this button, it is going to automatically run this select star for you. So if I just click this button here, it's going to show all the employees by running a select star from employees, right? And this is one other way to write something you will see often. You can also type database name dot column name, dot table name, and then put a query. So if you've not already set a default database using the use command, like use classic models, you can just put select star from classic models dot employees. So this is database dot table name. Okay. So here's an exercise. Add some customers to the database using data from a SQL file. So somebody asked can you add data programmatically? Can you add data which is already there somewhere else? So let me open up the SQL file, and this SQL file contains code for everything that we are doing today of this classic models SQL file. And in this SQL file, you will find some rows for inserting data into the customer table. So let's find it. Let's see. So here we have a bunch of create table statements. Then you have these insert statements for customer, for products. And then you have an insert statement for offices, employees, and okay. Here is where we have an insert statement for customers. So I'm just going to grab this. This seems like a whole bunch of insert statements here. So these are all the insert statements for customers. I'm just going to go back to the workbench and I am going to do a new query. I think, not sure which one it is. Never mind, I'm just going to edit it here. I'm just going to go to query 1, paste this. All right, so it seems like there are a lot of insert statements. I'm not sure why they wrote it like this. They could have written it all in a single insert statement too. But in any case, we have 125 customers. You can see here, you can see the details of these customers. These are typically, customers are stores. Remember, gift stores and toy stores buy the products from classic models. So customers are stores, and then each customer has a point of contact. If I go back here, you will see you have a customer name, and then you have a customer number. Customer name is the store name, contact, last name, first name is the information about who to contact, their phone number, etc. So all that information is captured here. You will also see an employee ID. So this one is probably the employee ID. And then you have, okay, so here there's also some kind of a location data. You see STGEOM from text, etc. So you can also put location data into MySQL. That's pretty interesting. So let's run this. Let's see if this gives a correct result. Yeah, seems like it was able to insert data into the customers table. All right. So now we've inserted data for about 120 customers, and we should be able to see that here in the response. Yeah. So you can see we have data for over 100 customers, and that's great. And some of them have a sales rep, some of them don't have a sales rep. Customers also have a credit limit and such. Okay. So now when you start getting to this point where you have a lot of rows in your database, then it may not make sense to look at all the data at once. That is where you may want to select some data. You may want to query some data. You may want to filter out data based on a particular condition. And that is where the where clause in the select statement becomes useful. So you have this where clause. So you have this clause called where that you can include after your select. So when you say select star or select some columns from the employees table, you can say where job title equals sales rep. Now if you go back and check the employees table here, you can see that employees table, there is a job title here. And let's say if you only want to get a list of the sales reps, so we say select star from employees where job title equals, and then whenever you want to put an actual value for comparison, you use double quotes, very important, sales rep. Okay. So select star from employees where job title equals sales rep. And maybe I can also select specific columns. So let's say I just want to select the last name, and I want to select the extension. Actually, let me just select the office code. Okay. So last name, first name, last name, and office code from employees where job title is sales rep. And now it starts to become more useful. So now we know that at office code 1, we have Leslie Jennings, who is a sales rep. At office code 2, we have Julie Farrell, who's a sales rep. At office code 3, we have George Vanoof, who's a sales rep, and so on. The where clause supports a bunch of operations. Where clause supports the equal to, which is what we have used here. It supports less than and greater than. So both of these work with numbers and with strings and with dates. So pretty much all data types. With numbers, they work as expected. 3 is greater than 2 and 3 is less than 5. With strings, they compare the alphabetical order. So A is less than B, and any string that starts with A is less than any string that starts with B. And so let's say AA is less than AB, and you can have this lexicographic or alphabetical order from A to Z is lower to higher. You can also have less than equal to or greater than equal to, and you can have not equal to. Now, some variations use this less than greater than. Some relational database software use this not equal to. So let's see what MySQL uses. How about we first try not equal to? Okay, MySQL seems to support this, but you could also have in some places this kind of a statement. So it seems like MySQL supports both, right? If I do star here, we can verify if that is actually the case. Yeah. So we are now getting the list of people who are not sales reps by using less than, greater than, or we can also do a not equal to here. All right. So here's what that looks like. You can also combine expressions in the where clause using and or. So let's say you can say things like select column 1, column 2, comma, from table name where condition 1 and condition 2 and condition 3. So for example, if we want to select the sales rep in San Francisco, so what's San Francisco? Let's first open up offices, and in offices, let's check San Francisco. That's office code 1. So if you want to get the sales reps in San Francisco, so we say select star from employees where job title equals sales rep, and we can put in the additional condition office code equals 1. And again, we should put this in quotes ideally. Okay, just a single equal to. Yep. So now you see here, we have the data for Leslie Jennings and Leslie Thompson, their extension and their email, and both of them are in office code 1, which is San Francisco. So that's how you filter data out. Like I'm just showing you here. It's going to be a little bit bigger here. So that's how you filter data out from a database table. You use the where clause. In where clause, you can have one of these conditions. You can also do something like this. You can use in, between, and like. And then you also have this option to negate things. So you can also negate a condition by saying where not condition. That's another thing to just keep in mind. And a where clause can be used with select, but it can also be used with update and delete statements. So we were talking about delete earlier. So maybe let's check out the delete statement once. And now from this point on, mostly you would just have to look up how certain statements work. So here we say delete from table name where condition. Now remember, we had this one office that I had inserted initially called Bengaluru, and this had the office code AAA. Now if I want to delete this office, then here's one thing I can do. Let me go back here. I say delete from offices where office code equals AAA. and that should have deleted the Bengaluru office. Let's see. So now you can see that we no longer have the Bengaluru office anymore because we've just deleted it. Now here I've deleted exactly one column, but I can delete multiple columns as well. Let's say if I wanted to fire the sales reps in San Francisco, so then I would do delete from employees where job title equals sales rep and office code equals 1, right? Instead of select star, I would just type delete. And then instead of just showing this information, it would simply remove these rows of data from the database. So that's that. And let's also check update. Similar, just like delete, we have update. So let's check update too. Now here's how update works. You say update table name, and then you set the value of column 1 to value 1, column 2 to value 2, column 3 to value 3, where a condition holds true. So let's try update. Maybe let us change the reporting person for Leslie Jennings and Leslie Thompson. So who are we going to set them to report to? Maybe let's set them to report directly to the president. Maybe Diane Murphy directly wants to talk to the salespeople in San Francisco. So we want to get these employees where job title is sales rep and the office code is 1. And we want to update their values. So let's see, we say update. What does that code look like? Update set column 1 equals value 1, column 2 equals value 2. Okay. So we want to set update employees and we want to set their reports to 1002. And again, we should put in quotes here. Update employees set reports to 1002, and then we want to have the where, and in the where clause is where we want to add this selection where we are only selecting the sales reps from San Francisco. So where job title equals sales rep and office code equals 1. Okay. All right. So the good thing about SQL is that it's very readable. So update the employees table and set reports to 1002 where job title is sales rep and office code is 1. So only for people in the San Francisco office who are sales reps, we want to update their employee. We want to update their reports too. And let's just do a select star and let's make sure that that was updated. Select star from employees. Yeah, so now you can see with Leslie Jennings and Leslie Thompson, they now report to 1002. Okay. If we remove this, we can also see that no other rows were affected. You can see that there are very few other people who actually report to 1002. All right. So that is the select clause, the where clause, the update command, and the delete command. So here are some exercises for you. Try and list customers in the United States with a credit limit higher than $1,000. So you'd probably start out something like this. You would say select star from customers where country equals, I think it's USA. You can check this out. So these are all the customers in the USA, quite a few of them, but we want customers with a credit limit higher than $1,000. Maybe we probably want an even higher credit limit, but let's see. Let's try a credit limit higher than $1,000. So here you would say country equals USA, and then you would say and credit limit greater than 1,000. Or let's try 10,000. Let's see if there are any with more than 10,000. More than 100,000. Yeah, so there are 9 rows with more than 100,000. But with 1,000, there are 35 rows. So you can see that changing the credit limit is going to change the number of results. All right. Then here's one more. List the employee codes for the sales representatives of customers in Spain, France, and Italy. Okay, how would you do that? Well, you would say select sales. First, let's describe customers. So let's say describe customers. So we have the sales rep employee number. So now we would say select sales rep employee number from customers, and then we can put in a where, and now we want the location of the customer or the country, and we can put in an in, and then I think we can give it a list of values. So we are concerned with Spain, France, and Italy. So we can now put in Spain. I think we have to use double quotes here. So Spain, France, Italy. Okay. So here is the list of all the sales reps who work with customers in Spain, France, and Italy. Okay. Now I can probably just put together a list of these. So there's 1370, 1337, 1702, 1401, and 14. Yeah, that seems to be all. So there are only about 4 or 5 such sales reps. And then the question is, make another query to list the names and email addresses of those employees. So now we can do select, let's say first name, last name, email from employees, where employee number, in, and then give it this list. Okay. So now we have Louis Bondor, Gerard Hernandez, Pamela Castillo, and Martin Gerard. So these are all the people who are selling to customers in Italy, Spain, and France. So this is the kind of Q&A that you can do using SQL queries. Here's one more: change the job title sales rep to sales representative. I'll let you work on this. You can use update to do this. Delete entries for the sales representatives working in London. So first you find out the code for the London office. How do you do that? Well, you can use a select statement to get the data for London. Then you use that code, that office code, to delete the entries for those sales representatives. So you'll have a where clause with delete. Then you have show a list of employees who are not sales representatives. I think we've already done that. And here's one interesting one: show a list of customers with toys in their name. So this is where you would have to use the like statement. So if I just click through here, you can see this is how the like statement works. So you can say select columns from table where a certain column is like a certain pattern, and the pattern can be a string, or the pattern can be something like this. You can have a percentage or percentage a. So whenever you have a percentage, that means 0 or more characters. So if you want to just check for a somewhere in between, like if you just want to check for or somewhere in between, then you have percentage or percentage. So percentage represents 0 or more characters, and then underscore represents exactly 1 character. Okay. So check out this reference on how exactly it works. What I'm going to do is I'm going to just try and solve this answer: show a list of customers with toys in their name. So let me see, select star from, or maybe just select the customer name and the country from customers where customer name like, and here is where we can put in percentage, and then we want toys and percentage. And let's run that. Oops, I think I had to close it. So let me just undo that. Percentage, toys, percentage, and let's run that. Okay. So it seems like you have land of toys incorporated in the USA. You have toys of Finland in Finland, and you have toys for grown-ups in USA and boards and toys in USA. So it's a very basic selection. You can't do a lot of advanced regex kind of selection, but a very basic selection can be done. A very basic search can be done using like. Okay, then you have product lines and products. So you have a bunch of product lines like motorcycles, flights, planes, cars, etc. And then you also have products. So you may have different models of motorcycles, different makes for which you offer small scale models. So here is what they look like. Product line is a very simple table. It contains the product line. It contains some description. So it seems like it contains a text description. Here, for some reason, there's also an HTML description. Maybe this is going to be used on the website. And there's also an image. Yeah, so let's just create the product lines table. Once again, I'm just going to paste it here, and that will create the product lines table. And similarly, we have the products table as well, which has the product code, product name. Product code is the primary key. It has a product line, which is a foreign key. And it has a product vendor, description. It has a quantity in stock, so that's a small integer. Then it has a buy price, so which is the price at which we are buying, let's say, the raw materials for the product, or sort of the manufacturing price. Then we have the retail price, so this is the price at which we are selling the product. So that can be used to just determine the profit on the product. So here's our product, right? And then once again, you can use this link to download some products. So here we have the SQL file, and then from the SQL file, let's find some product lines and some products. So let me get all these product lines. I'm going to come back here, and I'm going to just put all these product lines in, and I'm going to just run this. So we have put in all the product lines: classic cars, motorcycles, planes, ships, trains, truck, vintage cars. And let's also put in a bunch of products. Let's get all of these products from this page. Okay, quite a few products. And let's put it in there. There you go. So now we should have a bunch of products and a bunch of product lines as well. Okay. Now, once you have such huge tables and such a large number of products and product lines and such, you may want to do some sort of ordering, and you may want to also limit the number of results. You may not want to look at thousands of results all the time, or even hundreds. You may just want to look at the top 5 or top 10. So if you want to order data, then you just include order by at the end of a select statement, and you just mention which columns you want to order by. So column 1, column 2. So first it will try to order by column 1. If the values in column 1 are equal, then it will try to order by column 2, and so on. And then you have the ascending and descending. For example, if you want to list customers by country, you would say select, let's say, customer name, comma, country from customers, order by country. And now you can see that you have customers ordered by country: Australia, Austria, Belgium, Canada, etc. You can also then use a limit clause if you just want to then see maybe just one page of data, something that you can display at once. So you can also type here limit 10. And now you just see 10. And of course, you don't have to use order by with limit. You can use limit without order by as well. So if I just do limit 10, so this is now the natural order, or the order in which the data was inserted. That is the default order that is used. So this is how you combine order by, limit, and then you can also combine it by where clause. Maybe you can also only check for customers which have a credit limit greater than $1,000. So let's say select customer name, country from customers where credit limit greater than 100,000 and order by country limit 5. Right, so maybe also get the credit limit here. So that's how you combine all of these. Here we are combining select, we are combining where, we are combining order by and limit. And this is what that looks like. Okay. So here are some exercises for you. Identify the 5 most expensive products from the planes product line. Identify the products that are about to run out of stock. So products which have a quantity in stock less than 100. And list 10 products in the motorcycles category with the lowest buy price and with more than 1,000 units in stock. Okay. So there are a lot of things. You'll probably have to put together everything that we have covered so far. Order by, and not order by, but you will have to put together a limit. You will have to put together an order by as well, because the lowest buy price, and you have to put together a couple of conditions, which is the category, product line. And for the product line, you will have to figure out what the product line code for motorcycles is, and you will also have to add a check on the units in stock. Okay. Then you have these orders, order details, and payments tables. So I'll let you build these as an exercise. You have the code, you have all the information here. So you can create the order details, and payments tables using the create table statement, and include proper primary key and foreign key constraints. So for example, order has a customer number, order details has a order number and a product code, and then payments also has a customer number, and the check number is the primary key. And then you can use the same sample data that we've been using so far to populate this too. Okay. Next, I just want to briefly touch on how you can modify the structure of a table. Not something that we will do right now, but if you want to add a new column to a table, here's how you do it. You say alter table, table name, and then add, and then the column name and the data type, and that's going to add the column. Maybe let's do it very quickly for employees. So alter table, let's see employees, let's check the employees table first, employees. So describe employees, and now let us maybe add the date that they were hired on. So we will say alter table, employees. What's that? Add. Yeah, add, and then the column name hired on, and we want it to be a date. Okay, seems like that was added. So now if we check describe employees, you should see that there is a hired on column. And if I want to insert an employee, insert into employees. Yeah, if I insert an employee now, I can probably then add some information. Let's say set employee reports to, etc., etc. So we can probably set the hired information, right? So hired on to 1002, and let me change this to an actual date. So 2020 12/01. Okay. So now if we check employees again, let me just get these employees. So select star from employees, where job title is such and date is such. So you can see now with these employees, we have a hired on column, and in the hired on column, the value is 2020 12/01. And for the other employees, you will see that the hired on column does not have that value. So that's how you add data. Nothing too special, nothing too complicated. It's just one more thing to know. You add a column, and similarly, you can drop columns using the drop column command. You can modify column using the modify column command. You can rename column using the rename column command. And here you say rename old column name to new column name after alter table. So as an exercise, try adding, removing, and modifying one column in each of the tables created. And check what happens when you remove or rename a column that is a primary key, because that is a primary key which is also used as a foreign key. Yeah, so do try that out. So if you change the employee code, for example, the employee number, now that is used in a bunch of different tables, like the customer table. So what happens when you change the employee number column? Try it out. That's the best part about interactive environments like this. You can try out things and you can break things and figure out what happens. Now you can also place a bunch of SQL commands into a .SQL file, like this one that we've been looking at so far. And then you can execute all of these commands together. You can see that here we are dropping the database. We are then creating a database. We are then using that database. Then we are creating a table offices. We are creating a table employees. We are creating a table customers, product lines, products, orders, order details, payments, and then we are inserting data into each of these tables, right? So this SQL file is basically what's called a database dump, that somebody had this database and then they exported it, and we'll see how to export it as well. But now you can take this data and import it into, or just run all these SQL commands and automatically import the data into your SQL server, into your SQL database. And here is how you do it. So there are two ways to do it. One is through the command line. Now through the command line, let's say I go back here, I exit the actual command line, and let me come to my desktop, which is where I have this file, database.sql. So I have this file here, database.sql, and I can check this file. It contains exactly what I was looking at. I have just downloaded this file here. So I find my MySQL binary, which is in /user/local/MySQL/bin/MySQL. So this is the MySQL command line tool. And then I say -u root. So I want to log in as the root user. And then I also say -p because I want to use a password. And then this is the magic part where you use this less than symbol. And I'll tell you how to think about this. So you have this less than symbol, database.sql. So what you're indicating here is take the data in database.sql and pass it as inputs to this command. So now we're no longer opening up the console, but we're taking all of these commands inside the SQL file and passing it as inputs to MySQL, which we are logging into as the root user. So when I run this, let me just to make things very simple, what I'll do is I'll first just open MySQL /user/local/MySQL/bin/MySQL. So I'm just going to open this first, -u root -p. I'm just going to open this first and I'm going to drop database classic models. Okay. And let me just do show databases. And you can see that we don't have classic models here. So now we run this code, MySQL -u root -p database.sql. And this should take all those lines of code and it should execute them against this server. Yeah, it'll take a minute or two, but it's done. And now if we come back here into this, or if we just open up MySQL now and just log in and do show databases, you can see that we now have classic models, and it is now showing up in a uppercase because in this script file, the database, when it was created with this uppercase C and uppercase M, but as such, you can still just say use classic models without uppercase. So you can just say classic models and it should work just fine. And now you can do show tables, and you have all these tables, customers, employees, offices, etc. And now we can do select star from offices, and you can see that these are all the offices that we have, right? So even though it shows up as uppercase here because that's how it was created, but you can still access it as lowercase, uppercase, or this title case or whatever, right? So we have taken all that information and then we have taken all these lines of SQL code and we have executed them on the database. So that's how you execute data. One other way to do it is you can also do it this way from MySQL Workbench. You can click on this, you can see Open SQL page, Open SQL button. So you have this Open SQL file button here, the second button, click on it and go to desktop and just open it up. Now, depending on which database you're using, the UI will be a little different, but the concept here is that you can do this. You can take a bunch of SQL code and then you can execute all at once and it should do the exact same thing. So here it drops the database. So it's going to empty the database and then it's going to add all this information. And now if you just refresh here, you should find classic models, and inside it, you should find these tables, and then you can maybe click on employees and you can see all the employees. So you have all the employees just fine. One other thing you can do is you can export data out. So there are a couple of ways to do this. One is to use the MySQL dump utility. So the same place where you have the MySQL utility, which is at, let me just exit here. So we have at user local MySQL bin. Again, this will be different on Windows or probably different on Linux as well, but you can find it quite easily. Just look it up. So user local MySQL bin MySQL, right? So this is how you open the command line. This is what we have been looking at so far, but you have a MySQL dump utility. So you can call MySQL dump, and I want to use the root user and I want to use a password. And how does it work? So we have to provide it the name of the database. So we provide the name of the database after -u, or even at the beginning. So MySQL dump, the database that we want to dump is called classic models. And then there are certain options that you can specify, that do you want to have these drop table lines? So if you see here, before every table creation, there's no drop table statement, but we can add that drop table statement as well by specifying this option. And again, you would just have to look up the documentation online as to figure out how exactly all these options work. But yeah, MySQL dump, add drop table, classic models, -u root -p. Okay, and that has created this SQL file. Oh, but we forgot to write it to a file. We want to actually write it to a file. So right now it has just printed it out. So what we want to do is, instead of printing out all this information, we want to write it into, let's say, dbdump.sql. Okay. And just like that, there should be now this file dbdump.sql, which should have all the information that we're looking for. So it has this drop table if exists customer, then create table. And then below it has the data for customers. So insert into customers, and you have all this customer data. And then you have data for employees, then you have data for offices, and so on. Okay. Now there seems to be some encoding error here. For some reason, this is treated as binary. I think it's probably the office location that is causing an issue. But as such, everything seems to be just fine. And then you can take this and then you can use that to reload the data. Now here it does not have the commands to actually create the database. I'm sure there is some option that you can specify in SQL dump to create the database if it does not exist, and drop an existing database as well. So I'll let you figure that out. But yeah, but this is what we are interested in. And this is something you can do. If you connect to a remote database, right now we are connecting to a local database, but if you connect to a remote database on some server, you can export all its data into a SQL file. And then there are converters in pandas. What you can do is you can actually load up SQL files. Maybe let's try that. Maybe let's do file open here and let us upload. I'm not too sure, but I think this might work. So let us upload database.sql. Yeah, and you should be able to do something like this: import pandas as pd, and then pd.read SQL. And let's see. Oh, I think this needs to be a SQL command and a connection. So it's not going to work with a SQL file. You need to actually connect to a database. So we look at it the next time. But yeah, but there are ways to read that SQL file. There are ways to convert SQL files into a bunch of CSV files. I know that there are ways to convert that into a bunch of different formats. So exporting it is useful because you can then load back that data into a new database server, or you can also convert it into different formats. So try this out on your own. Download the SQL file, import the data from your local installation of MySQL server, and then export the classic models database into a SQL file, then drop the classic models database and then recreate it using your exported file. So make sure that your exported file can actually recreate the data. That's an important thing you should be able to do. Okay. So with that, we reach the end of today's lesson. There's not much more that we're going to cover today. There is a lot more that we need to cover in SQL, but we'll talk about the next time. But here are some challenges for you to try out. So this classic models dataset is taken from this website, richardwatson.com. I think this is a professor and they teach a database management course. So you can, and there are a bunch of exercises here. So today what we've covered are mostly the single entity exercises, but you also have these other exercises which require some joins and some other things which we have not covered yet. So you may just want to try out this. Prepare a list of offices sorted by country, state, and city. This should be straightforward. How many employees are there in the company? Okay, this will require some sort of aggregation. Or you can just look at the list of employees. But one thing you should check out is you can check out things like count. Where's count? Yeah, count, average, and sum. So you can do something like this. Select count column name from table where condition. And you can use that to answer this question, how many employees are there in the company? So here is how I would do it. I would say select count star from employees and just use classic models. Okay. Select count star from employees and it tells you that there are 23 employees. Then here is a question, what is the total of all the payments received? So let's see, select star from payments and you have all these payments. And now among these payments, there is this amount column. So if you just want to get the total amount, we say select amount and then we can do a sum. How do we do a sum? Well, I think it should be there here somewhere. So we can just do a sum on the column. So we do select sum of amount from payments. So this is the total payment that we have received. Now you can do things like what is the total payment we have received from customers based in the USA or from a particular location. And you can do like a group by as well, and we'll cover group by and all the next time. Then you have questions like list the product lines that contain cars and report total payments for October 28, 2004. So here's a where clause, report those payments greater than $100,000. List the products in each product line. How many products in each product line? Okay. So this might be worth figuring out. You may have to use this as a reference. W3 Schools is a good reference here. You can check out and see which one of these might be useful for you. Then what is the average percentage markup on MSRP on the buy price? So now you're doing arithmetic between two columns. Again, something that we'll try and cover the next time. How many distinct products does classic model sell? Report the name and city of customers, etc., etc. So a whole bunch of questions, and whichever you are not able to figure out right now using what we have covered today, just try and look through this documentation. So this is everything that MySQL supports is listed here. Most likely everything that you need will be covered in this MySQL SQL section. If you just go through most of these, you should be able to answer these questions. And then wherever we have more one-to-many relationships or any relationships between multiple tables, we will look at the next time. So the next time we will look at using functions for advanced querying on strings, dates, timestamps. We will look at aggregating data using count, average, sum, min, max. We will look at using joins to combine and query data from multiple tables at once. We will also see how to improve query performance with keys, indexes, and transactions. And finally, we will look at how you can connect to a SQL database from Python for querying and visualization in Jupyter. So we'll look at how to do it using pandas, and we'll also briefly try and look at ORMs. So there's a bunch of things to cover here, but the more important thing in SQL is practice. So you want to definitely try out these challenges, and there are solutions for these challenges as well. You can click the solutions link and use that to check the solutions. For example, there was this query about what is the average percentage markup of the MSRP on buy price. This is question number 11. So let's see question number 11. Okay, so seems like we are doing some sort of a calculation here. So average of MSRP minus buy price divided by MSRP multiplied by 100 as the average percentage markup from products. Okay, so we'll also talk about as the next time. Now, a few resources for you. One is the SQL challenges for sure. Then the other one is the W3 schools reference. It's a great guide to just quickly look through all the different SQL commands and all the different SQL statements and keywords that are present. Then there is this book called dbbook.com. So this is db-book.com. It's called Database Systems Concepts. You can get this book if you wish. It's a great book, but you should also check out these slides. So they have made the slides available for free online. And these slides are a great comprehensive introduction to SQL and relational databases and pretty much everything to do with relational databases. So you can use these slides just whenever, let's say, you're preparing for interviews or if you want to get a deeper theoretical understanding of how the whole thing works. Do check out these slides. I think you'll find them useful. Now, you just need to look at part 1, relational languages, where we talk about relational models, introduction to SQL, intermediate SQL, advanced SQL. Advanced is already beyond what you will need to know, but if you cover these 4 or 5 slide decks and maybe also the introduction, then you will pretty much master SQL. At least you'll know everything there is to know. Then you'll just need to practice. Then you also have these slides on database design, which is about the entity relationship diagrams and models. You don't need to know this as a data science practitioner. Generally, somebody else is going to do the database design. But if you want to interpret entity relationship diagrams correctly, then you should check this out. This might be useful for you. The rest of it is not really that important, not something that is relevant here. It goes into the internals of databases. But definitely check out chapters 2 to 5 of dbbook.com. So you want to go to db-book.com, go to the 7th edition and click on slides. And here you have all these slides that you can access. Here they also have some sample tables. Just like we had this SQL file for creating the classic models dataset, similarly you have sample tables for creating this university dataset. So where you have departments and instructors and students and courses and prerequisites, and students take courses and instructors teach courses, and then each course is taught in a section with a certain time slot, and then instructors are also advisors for students. So it's an interesting dataset. It has about 2000 rows of data. And then there are a bunch of questions that you can try and answer on this dataset as well. I think they're mentioned somewhere here in the exercises. So you see there are some exercises here on accessing the database, basic SQL, intermediate SQL, advanced SQL. So here. So there's SQL is all about exercising, all about trying out these exercises. So maybe we'll try and put all of this together into a single notebook, and we will also find a way to do it so that you can type all the code in Jupyter and get the results immediately. In fact, Jupyter, just like Python, there is a way to type SQL directly into Jupyter and interact directly with the database. So we'll try and set that up for the assignment. But in the meantime, do check out dbbook.com. You also want to get familiar with the workbench or whatever tool your company is going to use. So don't lean too much on Jupyter for this particular course, especially, and SQL in particular. Become used to this workbench, become used to working with the command line and typing commands there, because that is how you will be working with SQL databases in the real world. Okay. And we will touch on how to access them using Python too. More SQL exercises on w3resource.com. You have more exercises, hundreds of exercises really. And that's all SQL is about, exercises and more. And if you really want to read through MySQL's reference manual, then you can check that as well. Although you would almost never need to do that. And that's it. So we've just covered the use cases and the design of relational databases in SQL. We've looked into the installation of MySQL and how to set up a database locally. We looked at creating, modifying, and deleting databases and database tables. We looked at SQL data types and constraints like primary key and foreign key. We looked at the create, read, update, and delete operations on database tables. And we looked at exporting and importing data from relational databases. The topic for today is aggregation and joins with SQL. Last time we looked at some basic SQL commands. We saw how to create databases, we saw how to create tables, we saw how to put data into tables, how to get data out of tables, all the CRUD operations, which is create, read, update, and delete. And we also looked at basic querying using select with some conditions. Today, we're going to look at aggregation, grouping, and pagination in SQL queries. Then we will look at mapping functions, arithmetic, and how to work with dates. We will also combine data from different tables using SQL joins. And we learn how to improve query performances with indexes and views. We will also talk about how we can execute SQL queries using Python and SQL Alchemy towards the very end. And as I've said, this is a continuation of the previous tutorial, so do check out the previous tutorial if you haven't done that already. This contains all the basics of SQL. And we will be setting up a MySQL server locally. So typically how a relational database works is you have to download this software called the server. And a server in computer science is simply a program which runs in the background and listens for instructions. So the MySQL server is something that you can download from dev.mysql.com. This is just a package that you download to your computer, and then you install it on your computer. And once you install it on your computer, you can start up a database server on your computer. So that software is running now in the background, and you can then issue instructions or send instructions to the database server in the form of SQL queries, like creating databases, creating tables, putting data in, taking data out, etc. Now, depending on your operating system, the way to start and stop this server is going to be different. In my case, what MySQL does is when I install MySQL community server, it adds a system preferences pane. So inside my system preferences, this is the Mac system preferences, there is a MySQL page that gets added. But in your case, this could be different. So make sure that you have downloaded MySQL server, the software, and then it is running on your computer. And then anytime you have a server running, you need a way to connect to that database server. So there are multiple ways to connect to a database server. One of them is to use the MySQL command line, which is typically installed at some kind of a location like this, /user/local/MySQL. This is on Mac. Again, the MySQL command line tool based on your operating system will be at a different location. So check out the documentation or search online on where you can find the MySQL command line tool once the community server is installed. So one way you can connect to the server and issue commands to the server is by running the MySQL command line. And here you specify that you want to log in as the user root. So when you install the server, you're asked to set up a password for the database server and a username. So the default username is root and you have to set a password. So in my case, I have set up a certain password. And now I am connected to the server. And now I can issue commands to the server. For example, I can say show databases. And that's going to show me the databases I have. But what we're going to do is use this software called the MySQL Workbench. So this is the second piece of software you'll have to install. And I have given you a link here, dev.mysql.com/download/workbench. So go to this page and download the MySQL Workbench for your computer, for your laptop, for your operating system, and then open it up. So now we have a server that's running on a computer, and then we have this workbench which can connect to a server and gives you a graphical user interface to connect to that server. So one way you can connect to your server is click plus, and here you can then provide, this is a connection name that you can set, but you have to provide some parameters. By default, this is set to connect to a local machine, a local database server on your computer. But again, if you have a database server that is somewhere on the cloud, you can simply ask for the host name, port, username, password, and then you can connect to that server as well. So MySQL Workbench does not just connect to your local database. It can connect to any database on the cloud if you have the credentials. And when you join a company, they will give you the credentials to the server. In my case, I already had the local instance set up here. So I just clicked on it and now I'm connected to my local instance. For example, if I just type show databases, that's going to show me the databases that I have here, which is classic models, information schema, MySQL, and performance schema. And then I can run use database and all my select queries. Okay. So that's the setup you need to do. That's the software you need to have installed, and let us know if you face issues. And I hope the server and the workbench separation is clear to you. So here's the MySQL workbench. We have that running. And in this tutorial, we will use the classic models database from the previous tutorial. So classic models is a hypothetical company. It's a distributor of small scale models of cars, motorcycles, planes, ships, trains, etc. And the products that are manufactured by classic models are sold in toy and gift stores around the world. So here are some of the products they sell. And classic models has offices around the world with dozens of employees. And the customers of classic models are typically toy or gift stores. So each customer has a designated sales representative who is an employee of classic models that they interact with. Now, customers typically place orders requesting several products in different quantities, and then they pay for multiple orders at once via checks. All right. So that's the setup here. We have this hypothetical company which does all of these activities, and we want to track all their activities in a relational database. And to do that, an entity relationship diagram has been given to us, and this simply tells us what the different entities or what the different tables in the database are and what the different columns within those tables are. So we have an offices table. Here it contains information about different offices. The primary key is office code, which is the unique identifier. Then we have the employees table. So we have an employee number, last name, first name, extension, email, etc. And there are a couple of relationships here. There is an office code in employees. So for every employee, there is an office code, which is the office code of a certain office. So this is called a foreign key because an employee cannot have an office code which is invalid. And then you also have reports to. So reports to tells you which employee an employee reports to. So this is a foreign key from the employee table to itself, right? So reports to must be a valid employee number of another employee. Then you have customers, and you have a bunch of information about customers. Customer number is the primary key, and every customer has a sales rep employee number, which is the employee number of a certain employee who's a sales rep. And then for customers, customers can place orders. So every order is placed by a customer. That's why you have a customer number foreign key here. But apart from that, orders can have a lot of items. So there is an order details table for each item, each line item in the order. Let's say you've ordered 5 products, you have 5 line items, and you can have the quantity, etc. of each one. And then you have products as well. So there's a table of products and there's a table of product lines because you need to track information about the product somewhere as well. Finally, you have payments. Customers make payments at separate times. So this is a slightly different flow where you don't pay per order, but customers have a credit limit, which means they can place orders up to a certain amount, and then they can clear all their pending payments at once using a check. So that's the setup they have here. And depending on how your company operates, this system may be different. It's possible that if you take payments upfront, then maybe the order details is connected to payments, or the order is connected to a payment rather than a customer. Okay. So that's the entity relationship diagram here. And that's the sort of the overview of the database that we're working with. Now we will set up this database locally with some sample data using a script. So let me just set that up, and then we will take some questions. And by the way, if you have any questions, please post them in the Zoom chat. So to set up this database, we first need to download the SQL script. So I'm just going to open this in a new tab, and that's going to try and download it. And I'm just going to download it on my desktop here. And you can see that now the SQL script is downloaded on my desktop. And then once you have downloaded it, you can go to File, Open SQL Script in your MySQL Workbench. So open up MySQL Workbench, connect to the local database, and click on this, Open SQL Script. And then here you can see the contents of the SQL script. So this contains all the information to set up the database that we just saw, the ERD for the entity relationship diagram for, and it also contains a lot of sample data. For example, it's going to drop the database classic models if it exists. It's going to then create a new database, and it's going to use that database. Then it's going to create tables one by one. For example, here it's creating the offices table with all this information, and then it is going to create employees, customers, etc., etc. Once tables are created, it is going to insert data into these tables like product lines, products, customers, employees, etc. Okay, so it's going to set up a database with a lot of information for us. Now, once you have this SQL script loaded up, you will see this run SQL. So execute button, which is like a lightning button here. So you can just press that, or you can just press Command Enter or Control Enter on Windows. So I'm just going to run Command Enter, and now my previous classic models database has been removed and this new database has been set up. So if I go to the left sidebar, if your sidebar is not open, you can click here and open up the left sidebar and just go to the schemas tab in the left sidebar. I should be able to find a schema. Let me just connect again here. Okay, let me just run that once again. Yep. All right. So now if I check the schemas here, so I should be able to find in the schemas, once I reload the schemas, the classic models database. Now in the classic models database, I can browse all the tables here. You can see that we have tables customers, employees, offices, order details, payments, product lines, etc. And if you double click on a table, or if you just click on this table, click on this button which shows information from the table, then you can view some information from each table. All right. So MySQL Workbench gives you an easy way to browse the schema, see different tables, and actually look at information from different tables very easily. Okay. So now we have, just to recap, we have downloaded the SQL script from this URL, and then we have loaded it into MySQL Workbench using File, Open SQL Script. Then we have executed the script to create and populate the database. This part can also be done using the MySQL command line tool. It's simply a matter of passing the script to the command line tool, and you can look up how to do that. But once executed, you should be able to view and browse all the tables in the schema section of the sidebar. And if you face an error, the most likely issue is that your MySQL server is not running. So just because you have Workbench open does not mean the server is running. So make sure that the server is running, and then you will be able to communicate with the database server. All right. So with that, we have our database set up now, ready to go, and we have our MySQL Workbench connected. So let's get started. The first topic we look at is aggregation, grouping, and aliases. SQL provides several functions like count, average, sum, min, and max for aggregating the results of a query. What do you mean by aggregating? Well, it's combining the results that you get typically into a single number, or maybe one or more numbers. So here's an example. Report the total number of payments received before October 28th, 2004. Okay, so this is the kind of question that will be posed to you, or the kind of information that you will have to figure out. Now we know from the ER diagram, and we know from, let's maybe just copy the question and put it here. Yeah, so this is the way to create a comment in a SQL file or a SQL query, you just put in -- space, and that's going to be a comment that is going to be ignored by the MySQL server. Okay, so the question is, report the total number of payments received before October 28, 2004. So we have a table called payments. So let me just do a select star from payments. All right. And once I run that, I will get back a list of results. Yeah, here's the list of results. So these are all the payments in the database. You have a check number, you have a payment date, you have an amount, and you have a customer number, the customer who made the payment. All right. But we are not interested in all the payments. We are interested in payments received before October 28, 2004. So there is a payment date here, and it seems like this payment date is in this year, month, date format. And in fact, if you want to know the data type of this payment date, you can just spin up a new query here and just type describe payments. And you can see that the payment date is a date time. Okay. Now a date time is an ordered field. Obviously dates have a intrinsic order. So here's what you can do. You can say select star from payments where payment date is less than, because we want payments before October 28, 2004. And then you provide the date that you want to check here. So that's 2004. And then you have October, that is the 10th month. And then you have 28. So this should be enough. You don't need to put in the time here. So I'm just going to run that. And if you see now, we only have payments that have occurred before October 28, 2004. And I recommend just going through this list manually if you want to verify this. But that's how you get that. All right. But we don't want every single payment. We want the total number of payments. Now, if you want a total number of payments, it's very simple we simply want to count the number of rows that were returned by this query. And the way to do that is just type count. So count is a function in SQL, and you can see it highlighted in green. And typically this is what we do. We put all the SQL commands in. So typically this is what we do. We put all the SQL keywords on the SQL functions in capital letters or uppercase, and we put the column names in lowercase or whatever is the actual column name, whether it uses lowercase, uppercase, or combination of both. And this is just to visually separate actual keywords with column names. But remember that SQL is completely case insensitive. So you could type all of these in lowercase and you could type all of these in uppercase and it would work just fine. Okay. And this is just for visual separation. In any case, we have the count function. So you just put, instead of select count star, instead of select star, you just type select count star and run that. And now you will see here that there are 189 payments that have been made before October 28, 2004. And if you did not have this where clause, this filter, then you can see that there are a total of 273 payments. So out of 273 payments, 189 payments were made before October 28, 2004. So that's how you count the number of rows returned from a query. Just put in a count. Okay, and there's a quick question here about payments. Where did this payments table come from? So this is the table that we've just populated when we downloaded the SQL file, classicmodels.sql, and then we executed it. That gave us this table, and that gave us all the data inside this table. Okay. So that's count. Just put count around the selection criteria, and that will count the table. That will count the rows for you. Next, another common use case involves counting the number of distinct values in a column. So here's a question. Report the number of customers who have made payments before October 28, 2004. So now we are no longer interested in the number number of payments that were made. We're interested in the number of unique customers who have made payments, and one customer can make multiple payments. So number of customers who have made payments before October 28, 2004. So once again, maybe let's open up a new, let's just continue typing here. So here's my select query, select star from payments, and I can write payments, or I can write payments, or I can write payments, and it will all be the same thing. Okay, this is the name of the table. So anything you see after from is the table name. So select star from payments. That gives us a list of all the payments. And once again, we want to select them. Yeah, I'm just going to mix cases here, but don't worry about it. So let's just say select star from payments where payment date is less than 2004 10. What's that? October 28. So 2004 10 28. So that gives us all the payments that have occurred before 2004 10 28. Now we are interested in the customer number. We are interested in the unique customers who have made payments before this date. So here's the first thing I'll do. Maybe I'll just select the customer number first. Okay. So if I just select customer number, now I have ignored all the other columns. I have just selected the customer number column. So now I have 299, 172, 242, etc. But of course, there are probably going to be repetitions here, and you can go through this list and verify that there are some repetitions. Okay. So if I did select count customer number, this is giving me 189, which is actually the total number of rows returned. But we want simply the number of unique customers who have made payments. So what you do is you type distinct. Okay. Now when you type distinct, repetitions from this list will go away. So if I type distinct here, now you can verify that this list is a bit smaller. This list is not that big anymore. And in fact, if I type count now, you will see that the count is only 98. So what distinct does, when you type distinct before a column name, it is going to just select distinct values of that column. And if you type multiple column names after distinct, it is going to just select all the distinct combinations. But in this case, we first get the list of all the distinct customer number, which is a customer ID, and then we count the number of rows. Okay. So count is a function, but distinct is still a keyword, which is part of the SQL syntax. Okay. So once again, I'm just quickly going to repeat that. We have select star from payments where payment date is less than October 28, 2004. Now, instead of selecting all the columns, I just select customer number. And that gives me the customer number for each payment, but I'm only interested in the distinct customer numbers. I don't want customer numbers to show up again and again. So I type distinct and then I want to count them. So here is the count function, which is going to count the customer numbers for me. And there are 98 of them. Okay. So that's how you solve any SQL query or solve any SQL question. You just go step by step. You start by looking at the table and then you simply keep adding in criteria one by one. Of course, as I said, distinct can also be used without count. So if you just wanted the list of customer numbers for customers who have made a payment before the 28th of October 2004, then you just type select distinct customer number from payments where payment date is less than 28th of October 2004. Okay. And you can use distinct with multiple columns as well. So if you want to try out, learn more and try out what distinct does, just check out some documentation here on W3 Schools. And you can also practice this online. Okay. Now, if I look back at this query, just the distinct customer numbers, this is just giving me a list of customer numbers, right? And this is not very informative because ideally what we want is details of those customers. I want to know which people, which stores have made payments before the 28th of October 2004. So how do you do that? Well, here is one way to do that. We know that this is a list and you can write a query which uses the result of this query. Okay. And here's what we want to answer. We want to retrieve the details for all the customers who have made a payment before October 28, 2004. Okay. So how do we do that? Let me just put this query aside for a second and let me start typing, and let's just comment it out here. And let me start typing select star from customers. Okay. I guess I'm just going to use lowercase here, but select star from customers. So now I have details of all the customers, but I'm not interested in all the customers. I am interested in simply the customers where the customer number is in this list that I had earlier. And I'm just going to run this again here as a new query. So I just want to get the details of customers who are in this list, about 98 or so customers. So what I can do is I can take this query without the semicolon, and I can come back here. Select star from customers where customer number in, and then here I have to give a list. So instead of giving this actual list, I can give a query which generates that list. So I can just put in a bracket here and type select distinct customer number from payments where payment date. Okay. So we take the result of this query, select distinct customer number from payments where payment date, and then we run a second query, which is going to select details from the customers table where the customer number lies in this list. Okay. So if we run that now, so now you will only get details of customers where the customer number is in this list. And what is this list? This list is simply the distinct customer numbers from the payments column where the payment date is less than 2004-10-28. Okay. So that's how you chain SQL queries. You can take the result of one SQL query and use it in a where clause, or you can even select from it again. So you can treat the result of a query as another table essentially, and then write SQL queries on top of the results of other SQL queries. Okay. So that's how you chain queries. Okay. So here's an exercise for you. Retrieve the details of all the customers in the United States who have made payments between April 1st, 2003 and March 31st, 2004. So how would you do this? You would first think about it. The way you would do this is first you would just look at all the payments. So you just do select star from payments, and then you would look at payments between April 1st, 2003 and March 31st, 2004. So you would put some kind of a where clause where you would combine two conditions using an AND keyword. And once you get the results for payments just between these two dates, then you simply retrieve the customer ID for those payments. And then once you have that list of customer IDs or the distinct list of customer IDs, you can use that to get the details of customers, and you add another where clause where you will check whether the customer is in United States or not. So it's going to get a little complex here, but I will let you figure this out. And if you're unable to do it, do ask on the Slack group and we'll help you out. Okay, so let's talk about grouping then. So here's a question. Find the total number of payments made by each customer before October 28th, 2004. All right, let's go back and let's try and solve this. So here's the question. Total number of payments made by each customer before October 28, 2004. So we say select star from payments again. So we want to show all the columns from the payments table. All right. And we just want to look at payments before October 28, 2004. So where payment date is less than 2004, 10/28. And now we want to count the total number of payments. So we could do this count, but this is the total number of payments across all customers. We want to count the number of payments made by each customer. So here's what you can do. You can provide a group by clause. So you can type something like this. You can say group by, Well, I believe it shows up after where. So yeah, this can sometimes be confusing which clause comes after which, but let's try here. Well, actually, let's start with that and then we'll see if that works. So group by, so you type select count star from payments and group it by customer number. So now you're just looking at count star of payments and grouping by customer numbers. Okay, I think this comes after. Yep. So you type select count star from payments where payments date is less than 2004-10-28 and you group by the customer number. So what happens here? SQL first creates groups of rows for each customer number, and then it computes the sum, or it computes the count of the number of rows for each customer number. So here it seems like for a certain customer there are 2 rows, for a certain customer there are 3 rows, for another customer there is 1 row, etc. But of course we also want to see the customer number. So what we can do is we can just take this customer number column and select that too. Okay. So anytime you group by a certain column, you can also show that column in the result. So here's what that looks like. Select count star from payments where payment date is less than a certain value. Select customer number comma count star from payments where payment date is less than a certain value, and group this data by customer number first. So first SQL creates groups for each customer number, then it performs this count star, and then it gives us a customer number and the count star. Okay. Now here's one other thing we can do. This is not very informative because we're looking at count star here. What we can do is we can just say number of payments. We can rename this count, the output of this count, as number of payments. Okay. This is called aliasing. So now you have this table where it says customer number and it shows you the number of payments, and you can see that the customer number 112 had 2 payments before this date. Customer number 114 had 3 payments. And for each customer in the database, you get how many payments they've made. Only the customers who have made payments before this particular date. So this is how you use group by. Grouping is very commonly used with aggregation functions like count. Okay. Now, apart from the count, you can also compute the sum of values in a column. So here's one thing you can try and figure out. Find the total amount paid by each customer, which is the sum of all their payments before October 28, 2004. So let's see if we can do that. I'm just going to once again select, star from payments here and just see what columns we have. So we have a payment date, which we have been looking at. We've been looking at this customer number, but there is also this amount. So what we want to do is we want to total up the amount for each customer. So let me go back here. So now I have select customer number, and instead of count star, which is going to count the rows, I am going to call sum, and I'm going to sum the values in the amount column. So count, you generally put in star because you're just counting the number of rows, so you don't have to specify a column. But when you want to compute the sum, you specify the column for which you compute the sum. So sum of amount, and I'm going to call that as total amount. Okay. So select customer number and sum amount, which I'm calling total amount, from payments where payment date is less than 28th October 2004 and group by the customer number. And that now gives you for each customer the total amount. So all we've done is we've replaced count star with sum amount. Okay, so these functions are generally work in the same way, sum, count, and you can also use them together. So here's an example. Find the total number of payments and the total payment amount for each customer for payments made before October 28, 2004. So how would we do that? Well, we have select customer number and then we have the total amount already. I'm just going to add another column here. So I'm going to say count star as number of payments, comma. Yeah, so we have select customer number, count star as number of payments, sum amount as total amount, from payments, where payment date is less than such and such, and then we group by customer name. So now we have for each customer, what is the number of payments they've made and what is the total amount that they've paid before this particular date. And you can try and remove this where clause and see that the result actually changes. And you see now that the result is different, right? So try and understand each part of the SQL query. The same SQL query is mentioned here. So try and understand each part of the query. And if you can make sense of it, then you are getting familiar with SQL. And here's an exercise for you. Determine the total number of units sold for each product. So there is a products column and then there is a order details column. I think let's take a look at that quickly. Select star from order details. So there is an order details table. And this contains the details of all the orders that have been placed. And then here you have the product code and you have the quantity ordered of that product in that particular order. And what we want to do is we want to find the total number of units sold for each product. So if I simply do group by product code, and here if I do product code and I do a sum, and in the sum I put in the quantity ordered. So now what we're saying is we want to group the rows in order details by the product code. And for each product code, we want to take a sum of the quantity ordered column. And if we do that and run this query, you should see here that we have the product code. And then for each product code, we have the quantity ordered. Okay. And that's how you answer this question. Again, becomes easier to understand once you try it yourself. So here's how I would go about working through this notebook. Just read the question. Don't look at the answer. Just immediately go to your SQL workbench and then start typing out and start figuring out how to solve the question. And if you're able to solve the question, great. If you're not, then you can look at the answer and again, don't copy paste the answer. Look at the answer maybe for a couple of minutes, try and understand what it does, and then go back and try to type it out again. Typing out code is a very important part of becoming familiar with SQL or Python or coding in general. Okay, now apart from sum and count, you can also do the min, max, and average. For example, if you want to figure out what was the maximum payment made by each customer before a certain date, you can do that. All you need to do here is in this table, you can maybe just add max amount as let's just call it largest payment. So now you have for each customer, what is the largest payment they've made? And you can see this here. The largest payment that they've made is this person has made is a $14,000. You can also add the minimum amount that they've paid. So smallest payment. So the smallest payment they've made is $32,000. So already we are getting some insights. It turns out that in this case, customer number 103, the largest payment is $14,000 and the smallest is $6,000. But for 112, the largest payment is $33,000 and the smallest is $32,000. So maybe this customer is just clearing bills as soon as they hit a certain amount, right? You can also then look at the average payment. So what is the average order amount? I think it is average. Okay. So what is the average amount? And this is the average payment. Okay, I think there's an issue here. I'm not sure what the average is called, but let's see. Average MySQL. It's called AVG. So let me just change that to AVG. Yeah. So AVG is the function name here. And you can see that the average payment for each customer is also shown here, right? So this is how you can do basic analysis directly within SQL. You don't even have to export the data. Although if you want, you could export it to a CSV file. That's an option from the MySQL workbench, but a lot of analysis can be done directly within SQL. Okay, so let's talk about sorting and pagination. Now, so far we've been doing all these queries, and through these queries we get a lot of information, but in a lot of cases we are interested in finding the top 10 or top 5 or the maximum value. So here's an example. Retrieve the customer numbers for the 10 customers who made the highest total payments in 2004. Or actually, let me change that to before October 28, 2004. Okay. So retrieve the customer numbers for 10 customers who made the highest payments, total payment before October 28, 2004. So let's try and answer this step by step. We want to retrieve the customer number. So we can say select star from payments. And once again, we are interested in payment date before 2004, October 28. Great, we have that information. But now we want to retrieve, we were interested in the highest total payment. So before that, we are interested in the total payment per customer. So if we do this, if we do a group by customer number, and then we select the customer number for each group, and then we do a sum of the amount column. So now what that gives us is the total amount paid by each customer before October 28, 2004. So we have that. But now we are interested in the people who made the highest total payment. So here's what we can do. We can type at the end order by. So we type order by, and then we tell the column name that we want to order by. So we want to order by this column, which is the sum, the total amount. So let me just rename this as total payment. So I'm going to call this column, the sum column, I'm going to call it total payment. And I want to order it by total payment. So let's run that. And order by generally comes at the very end. So now you have customer number 456. They have a total payment of 1679. Customer number 381 has 2755, and so on. But of course, we are interested not in the lowest. So this is ordered in ascending order, but we are interested in the highest. So to do that, you type DESC, descending. So ASC for ascending and DESC for descending. And let's run that. So now you have the maximum value. $331,256 was spent by customer number 141. Okay. And we have this information for all the customers, but the question asks only for the top 10 customers. And typically, anytime you issue queries like this in a very large database, you probably only want to look at maybe the top 10, the top 50, or the top 100. So here's how you can do that. You just call, at the end you type limit, and then you tell the number of rows that you want to see in the result. Okay, so if I type limit 10 at the very end, so that's going to just give us 10 results. You can see these are the 10 customers, 141, 124, 148, 151, and 320. Okay. And by the way, limit works without order by as well. You don't need an order. You can do a limit just like this too. So these are both independent. But in general, whenever you're doing an ordering, it's common practice to also limit the number of results so as to not put a very heavy load on the database. So that's what we created. Select customer number and sum amount as total payment from payments where payment date is less than this value. And we group by customer number, order by total payment descending, and limit the results to 10. Now, if you want to see the next 10 results, because we've just limited the results to 10, all we need to do is add an offset. So let's say we want to skip ahead. We want to skip the first 10 rows and we want to see the next 10 rows. We type offset 10 and just notice this number here, 320 and 93565. If I type offset 10, you will see that now we have 386, which is less than the previous value. So now I'm no longer looking at the top 10. I'm looking at the next 10. So customer number 11 to 20 when they are sorted by the total payment. And let's say if I set the offset to 5, if I set the offset to 5, so I'll just skip, this query will just skip the first 5 rows and it'll show me from the 6th row onwards, right? So limit and offset can be set independently. Limit tells you how many rows you want. Offset tells you how many rows you want to skip. Now here I've skipped the first 50 customers. So I'm looking at customer number 51 to 60. Okay, and I could maybe even, if I wanted, I could look at just 5 of these. So play around with limit and offset. They are used to limit and paginate the queries. SQL also provides mapping functions, and these mapping functions are applied to individual values. So now we're no longer combining multiple rows of data. Now we are just applying them to individual values. So here is a question. Display the full name of the point of contact for each customer in the United States in uppercase, along with their phone number. And we want this information to be sorted by the alphabetical order of customer name. Okay, so there's a lot going on in this question. And these are the kind of questions that you will see in interviews often. And don't feel intimidated, just go step by step. The first thing here is we want information about customers. So we go here and let's clear all this. And we just type select star from customers. Great. Now we have information about customers. Next, we want customers in the United States. So we have, what's that? We have this country column, and in country we have USA. So if I just type where country equals USA. So now I'm just looking at customers in the United States, and you can check here, then all of them have country USA. Okay, great. One more thing done. Next, we want to display the full name of the point of contact for each customer. So if you see here, we have contact first name and we have contact last name. So we could do this. We could just say, let's just print a customer name. I think that is something that we should display. And let us display contact first name. And let us display contact last name. Okay. All right. So now we have the customer name. We have the contact first name and contact last name only for those customers where country is set to USA. Okay. So display the full name. It's still not the full name. We are showing 2 separate columns, but we'll figure out that piece. But here it says we want to display these in uppercase for some reason. Or maybe we want to print them somewhere or copy paste this information somewhere. So how do you convert a string into uppercase? Well, there's a function for that. You just call uCase. So uCase is going to make it uppercase and LCase is going to make it lowercase. So I just call uCase on first name, and let me maybe do LCase for now on contact name. And you can see here, the first name becomes uppercase, all capital letters or uppercase letters, and the last name has become lowercase. Let me turn that into uppercase as well. So now we have both in uppercase. And notice that these are not aggregation functions. They did not combine all the rows into a single value. They applied this function uppercase to every individual value. So this was applied to Susan. It was applied to this row and this row and this row and so on. Okay. So that's why these are called mapping values. They take a column and they map that column onto based on a function. So that's why these are called mapping functions. Now, last bit here is, or maybe a couple more things left. One is display the full name. So we want to take the first name and last name and we want to combine them. So there are certain functions which can combine columns, and the combination that we want to use here is called concat. Concat is short for concatenation. So I'm just going to call concat here, C-O-N-C-A-T, and let me drop this for a moment. Let me just get rid of these. And I'm just going to do customer first name and, this is contact. So contact first name and contact last name. So now we've combined contact first name and contact last name, but there's a problem here. You see Susan Nelson, this is there's no space between them. Well, that's easy to fix. You just add a space here. And now you have Susan Nelson. And we want to make this uppercase. So now concat first name, etc. is the string that we're dealing with, or is a column that we're dealing with. So we just called ucase here. And that is going to now make that uppercase. Now you could do it two ways. You could apply it to each column first and then concatenate them, or you could apply it outside. Both will do the same. So now we have that. One last piece of cleanup is, let me just get this on a new line, is to simply rename this column. So I'm just going to call this contact name. Okay. So we concatenate first name and last name with a space between them, convert that to uppercase, call it contact name, and list it out. One last thing, we also want to display their phone number, and we want to sort by the alphabetical order of the customer name. So let's display phone number here. Let's just put in comma phone number. I think it's just called phone, if I'm not mistaken. Yeah. So now we have customer name, contact name, phone, and we want to order them. So we just put in order by, and here we put in, what was that number? Customer. We want to order by customer name in alphabetical order. So we can even just put in ASC here, or ascending, to mean increasing alphabetical order. So now you see we have this customer name, American Souvenirs, Automoto Classics, Board and Toys, Cambridge Collectibles, Classic Gift Ideas. All of these are customers in the USA. We have their contact name listed in uppercase. We have the phone number of the contact, and we have sorted this list in alphabetical order. That's how you answer SQL queries, and that's all we're going to do over and over for the rest of the session essentially. Here's another example. Display a paginated list of customers sorted by customer name with a country code column. And the country code is simply the first three letters in the country name. This should say country code. So the country code is simply the first three letters in the country name in lowercase. So here's how you can do that. We want to show customer, so just paginated list of customers. So let me open a new query here. Let me do select star from customers, and we want to show a paginated list. So we want to show where, we want to limit to, let's say 10 customers. So these are 10 customers. Then we want to sort them by customer name. So let's do order by. All right, it is sorted by customer name just fine. And then we want to show a country code column. So maybe let's just show customer number and customer name and country. So now we have customer number, name and country, but we are interested in something called a country code. And what's a country code? The country code is simply the first three letters in the country name in lowercase. So we want to get the first three letters out of every country name, and that can be done using this substring function. So instead of country, we put in substring country, and in substring you specify where you want to start. Now in SQL, numbering starts at 1, not at 0. So just be careful about that. And we want to take 3 values, I think. So we just say 1, 3. And yeah, so that gives us just the first 3 characters of each country name. And let me just clean that up here. So that gives us the first 3 characters from each country name, but we are interested in, we want to make it lowercase. So we just type L case here, and that's going to make it lowercase for us. And let's just rename that using as to country code. Okay. And there you go. So now for each customer name, we have a country code. For whatever reason, we need the country code. All right. So that's another function. Here's one last function. Display the list of the 5 most expensive products in the motorcycles product line with their price rounded to dollars. And the price is the MSRP column. Okay. Let's try and answer this too. 5 most expensive products in the motorcycles product line. So let's get rid of some of these. Okay, so let's see, select star from products. There's our products, a list of all our products. And here, one thing you will see is a product line. So we simply want to look at motorcycles. So where product line, the column product line has the value motorcycles. Okay, now we're just looking at motorcycles here. And we want to check the 5 most expensive products. So let's order them. Let's order by MSRP, maximum sale retail price, I guess. So yeah, we order that by MSRP, and we can also just type MSRP. It should not be a problem here. Okay, now they're ordered by MSRP, but of course we want the most expensive. So we type DESC, descending. So now you can see that we have only motorcycles, and we have ordered them in the decreasing order by MSRP. And we just want to see the top 5 products. So I'm just going to add a limit here. So let me just move this down. Yeah, so let me just add a limit, order by MSRP descending, limit 5. So now we have the top 5 products, and maybe we don't need all the columns. Mostly we just need, let's say, the product code and product name and MSRP. All right, this is the required information. There is one last condition here. We want to round the price to dollars. Maybe we're creating a report where we don't want to show the full price. We just want to round it to dollars. And the way you do that is just type round. So round function will do that for you. So now this number is rounded to dollars. You also have a ceiling and a floor function. So if you want to round down or round up, you can use those. But round does the job. And in round, you can also specify the number of decimal points that you're interested in. For example, if you want to see 1 decimal point, just specify round 1. Okay. So that's how you answer this question. 5 most expensive products in the motorcycle category. So that was about the mapping functions. You will not, there are a lot more mapping functions. So you generally don't need to remember all of them, although it will help again for interviews, for exercises. And as you solve more exercises, you will automatically start memorizing them. But there are a bunch of different functions that you can apply to dates, and you can apply to numbers, and you can apply to strings, all of them. And one other kind of function or operation we should look at is arithmetic. You will often have to combine data from multiple columns using arithmetic operations. So here's a question. Display the product code, product name, buy price, sale price, and profit margin percentage. So what's profit margin percentage? Well, you buy the product, or maybe you buy the parts for that product at a certain price, and then you sell it at a certain price. The difference is called the profit and the margin, and the percentage is basically the sale price, MSRP, minus the buy price, multiplied by 100, divided by the buy price. Okay, so that's the profit margin percentage. Sale price minus buy price divided by buy price, and convert that to a percentage by multiplying with 100. For the 10 products with the highest profit margin. So we want to show the 10 products with the highest profit margin. And we also want to round the profit margin to 2 decimals. So there's a lot going on here. Let's go step by step here. First thing is we want to get some information out of the products table, right? So let's go select star from products. Yep. So now we select a bunch of products. All right. And what are we interested in? Product code, product name, buy price, sell price. So let's get product code, product name, buy price, sell price. Okay, is there a sell price? I don't think so. There's just an MSRP. Yep. Okay, so now we have the information that we're interested in, but there is this last column that we need, which is profit margin percentage. And fortunately, I have the formula here. So here's what I can do. I can simply put in the formula here, comma, MSRP minus buy price. Let's get these on different lines. So MSRP minus buy price. And let's get that down as well. Yeah. So this is the profit. And if you divide that by buy price, so these are all column names, right? So you're saying we want to take values in the MSRP column, from them subtract the values in the buy price column, and then divide by the values in the buy price column. And we want to multiply that by 100 too. So let's just put in a multiplied by 100, and let's put the entire thing within a bracket. Okay. So now we have MSRP. Oh yeah. So now we have MSRP minus buy price multiplied by 100 divided by buy price. And let's just call that profit margin. So let's just rename that. So that's our profit margin. And you can see that the profit margin for this product, since we buy it at $48 and sell it at $95, is 96%. That is the amount of money that we've made on top of the buy price. And what are we going to do with the profit margin? Well, we want to show the 10 products with the highest profit margin. So let's add that. So that will be a sort or an order by. And now once we've created this column, we can use it here. So we can call ordered by profit margin, and we want to limit it to 10. And we want to see the highest profit margin. So we say DESC, descending, limit 10. Let's check that. Great. So now we have this product, the Chevrolet Impala. On this product, we are making a huge profit margin. We're buying it for $32, selling it for $80. So 150% profit. Actually, maybe let me just call this profit margin percent so that it's not confusing with the actual number. Yep. Now, the last thing we want to do is round the profit margin to 2 decimals. And that's easy. We just type round here and another bracket here. Well, I guess we don't, let's see, we probably don't need that bracket. And we want to round it to 2 decimals. So there you go. Now we have the profit margin rounded to 2 decimals. And these are the 10 products with the highest profit margin percentage. So these are the kind of queries that you should be able to answer by using arithmetic operations, by using sorting, grouping, and aggregation, and mapping functions. You can check out what other operators are supported in SQL. It's not just you have arithmetic, you have add, subtract, multiply, divide. You can divide, and you also have this modulo function, which is to compute the remainder. So you can do that as well. And then you have some bitwise operations, and you're already familiar with comparison operations as well. So comparison operations are typically used in the where clause, as we saw with the date. Talking about dates, SQL also provides several functions for extracting information like the year, month, etc. out of date columns. So let's look at an example. List the largest single payment done by every customer in the year 2004, ordered by the transaction value, highest to lowest. Okay. Again, seems complex, but let's break it down. We are interested in payments. That's what I can gather here. List the largest single payment. So I'm just going to go here and first of all, just do select star from payments. Okay, we have payments now. Next, we want the largest payment by each customer. Okay, so we want basically the maximum payment by each customer. So we can probably do a group by customer number. And then for each group of rows for each customer, we want the maximum payment that they've done. So let's call amount, max amount, and let's rename that to largest payment. Okay. All right. So it's starting to make sense now. So we select customer number, we select the maximum amount. So for each customer, we look at all the payments we've made and pick the one with the maximum amount, or pick the maximum amount among those. And of course, for that, we have to do a group by customer number. But we want to look at this in the year 2004. How do we do that? Well, we have a payment date, and we could check if the payment date is greater than Jan 1st, 2004 and less than Jan 1st, 2005 and things like that. Or we could simply do where and we could use this year function. So year is a function just like other mapping functions, and into the year function pass in payment date and just check if the year of the payment date is 2004. Okay. So that's our query right here. Select customer number, max amount as largest payment from payments, where year of the payment date is 2004, and group by customer number. And ordered by transaction value, right? So we want to order that by transaction value. So we should also probably put in order by largest payment. And let's run that. So it turns out that customer number 161, made the largest payment in the year 2004, and that payment was $2,434. Oh, well, no. We want to sort it in descending order. Yeah. So customer number 141, the loyal customer, made $116,200 in a single payment. And that was the highest payment in 2004 by a huge margin. Actually, you had to 84,410 after that. Okay. So that's how you pick out information from a year, from a date. Here's another example. Show the total payments received month by month for every year. Okay, this is interesting. So you want to show the total payments month by month for every year. So you want to see January 2003, February 2003, March 2004, and so on. So let's once again start with payments. Select star from payments. We have the data. Now we are interested in year and month. So we have a payment date. If we can just create a new column for year and a new column for month, I think that should just get us started. So I'm just going to create a new column for year. So I select star, which means I select all the columns. But apart from that, I also select year of payment date as payment year. And let's see that. So now we have a payment year over here. And let me just put that at the beginning. And then we also want the payment month. So we just type month and we type payment date. So from the payment date, we get the month and we call that payment month. So let's put that on a new line here, comma star. So we still want the other columns, or you know what, maybe let's just keep the amounts now, or maybe we don't need the other information. So select payment date year as payment year, month of payment date as payment month, and then the amount from payments. Yep. So now it tells us for every single payment, we now have a year and a date and the amount. But of course, we don't want like this is still showing us every individual payment. Like if I put a comma star here, you will see that we're still looking at if I just, instead of the amount, if I put star here. Okay, never mind. Yeah, so you can see that we're still looking at every single payment, even though we've created a payment year column and we have created a payment month column, we are still looking at every single payment individually. What we want is the totals for each month and for each year. So how do we do that? Well, you guessed it, we want to total up the amounts. So let's get rid of these other columns and let's just do a sum. And we want to get the sum of the amount. But of course, just doing a sum is not enough because we also need to do a group by, right? Because we want to first define groups. So for each month, comma year, we want to get a group of columns. So you want to get a group of rows. So you want to get all the rows which belong to January of 2003, all the rows which belong to February of 2003, and then sum up each group. So we type here group by, and in group by you can actually provide multiple columns. So we have this payment year column, and we have this payment month column. So now we have a payment year, we have a payment month, and we have the total sum. So this is the sum of the amount of all the payments made in that particular month of that particular year. And maybe we also want to order by these same criteria so that we can see it in a more understandable format. So we also order by payment year and payment month. And you don't need this comma here. Yeah. So now we have 2003 1, and the sum is $26,000, and then 2003 2, which is February of 2003, and the sum is $144,000, and then 2003 March is $199,000, and so on. Seems like, what is this, September of 2003 was pretty good. So this is how you can now start doing some basic analysis and interpretation. So this is your revenue growth, or this is your revenue table. So if your boss asks for a month-wise revenue table, this is what you give them. But of course, you probably don't want to show these numbers like this. Like, it doesn't make sense to look at this 00003 here, and there's probably a floating point or a rounding error somewhere. So let's make these a little prettier. And here again, it's a bit difficult to guess the month. From month number going to the actual month can be a bit difficult. So let's make this a little prettier. Now for the above query, the query that we just looked at, let's format the amount properly with a dollar symbol and comma separation. Maybe show it something like this, 26,267.62, and just two decimal places. And let's also show the month as a string. Okay. So now we are in the territory of printing things nicely, of making things look good. So that's where you need these formatting functions. There are two functions. One is the format function for numbers, and then the date format function for dates. So let's first look at the format function for numbers. Now, instead of showing the sum, just the sum of amount, I am going to call format here, and I'm simply going to put in, I think to format, you can mention how many decimal digits you want. So I'm just going to put in 2 here, and format is automatically going to add commas here. So now you can see that you have 144,384.36 just by adding this format keyword here. And of course, now it's no longer a number, now it has become a string. And let us also rename this column as revenue. So now we have revenue is 144,384.36. Maybe let's go a step further. Let us add a dollar symbol here. How do we add a dollar symbol? Well, this is a string and we want to add a dollar symbol at the beginning of the string. How do we combine two strings? That is done using concatenation. So let's call concat, the concat function that we saw earlier. But this time, instead of concatenating two columns, we are concatenating a string, the dollar symbol, with the column. So now when we call concat, we have $144,384.36, and that is called the revenue. So that's how we format the numbers. A small cleanup that you can do here, especially if you're sending it out to somebody, this result is maybe you want to just clean up these column names. So if you want to just call it payment year, but of course that's going to be a problem. So whenever you have spaces within column names, you can use these back quotes. So this is the quote that is available on your keyboard just below the escape key. And let's call this payment month. Okay, and then let's call this revenue. I think this should be fine, just like this. And once again, let's just change it here. Just cleaning it up a little bit to make it look nicer. And then you can export it and send it as a CSV or something. So now you have payment year, you have payment month, you have revenue with dollars looking good. But of course, we're still missing this piece. We want to show things like January, February, etc. here. So if you want to show Jan, Feb, etc., here's what we can do. We can call date format. So there is this function called date format, and date format is something you will most likely have to look up. So date format takes a date as an input, and then it takes a certain format in which you want to see the date. For example, if you want to see the YYMMDD format, then you put something like %y hyphen %m hyphen %d or something. And here are all the variables that you put in. So inside these quotes, as the second argument, you provide all the variables that you want to show. And based on that, it is going to show you that information. So we are interested in, we have a month here and we want to show that month. Actually, we just want to show the payment date as a month. So I'm going to remove this month. I'm just going to call date format here. And how do I want to format it? Let's see what options we have. So there is this %b here. So I can take this %b. And if I just take this %b here, let's see what happens. So you see here, now this has become August. And in fact, if I want to get the year name, I think the year would be %y. So if I want to get the year name, I would maybe just put this. And now you can see August 2003, December 2003, etc. But I just want to keep the month name here. So now we have the month name. So we took the date, called date format on it, directly on the date, and we just extracted out the month using this %b. And that is something that I looked up in this table. There's no way I can remember all of these, so I just have to look these up each time. And we saw that %b can give us the abbreviated month name. If you want the full month name, then we can use %m. That can give us the full month name. Let's try that too, maybe. Okay, so yeah, so now you have the full month name. But now we've run into a problem because now we have payment year and we have payment month. But now because we are ordering by payment year and then payment month, the ordering becomes alphabetical. So we want to display the number, we want to display the string, but we want to order by the number. How do we do that? Well, here's one idea. I create another column. Let me just call that, let's use month and payment date. So let's get the month from payment date and let's call, this is called that as month number. And I'm just going to, instead of ordering by payment year and payment month, I'm going to order by month number. Okay. And let's try to run that. So that gives us an error because now since I have this new column month number, I should also be grouping by this column. Otherwise, anything other than the aggregation. So here is where we are doing the aggregation. Anything other than the aggregation should show up in group by. So let me just put month number here. Okay, so now we have 3 columns which we have created. We've created a payment year. That's fine. And we've created a payment month. Great. And we've created a month number because we also want to track numbers here. And then we are grouping by payment year, payment month and month number. Of course, payment month and month number represent the same information. So the same groups will be formed. For every month of every year, we will get a group of rows. And then we are taking the sum of those rows to get the sum of the amount. Then we are formatting it to add commas and show 2 decimals. And then we are adding the dollar symbol and we are calling that column revenue. Okay, so this is looking good. This is a pretty complex query at this point, but it's looking good. The only problem I have is that there is this last month number column here, which I don't like. This is not something I want to send to the person who's asking for this information. So how do we remove that? So in some sense, we want to use this column month number for grouping and for ordering, but we don't want to display it. Here's how you can do it. It's a very simple trick here. Just remove it from select. So you select payment year, payment month, you select revenue, but you remove this from here, remove the month number column and just put that here. So just put it in group by and put it in order by. Okay. So now we're saying we select year and we select this payment month, which is nicely formatted, and we select this sum, which is nicely formatted as revenue from payments. But in group by, we are grouping by this additional condition, this sort of hidden column, which is the month payment date. And we are also ordering by this additional hidden column, which is the month payment date. Okay. And now we finally have 2003 January, 2003 February, 2003 March, 2004 January, February, March, 2005 January, February, March. Okay. Now this is the perfectly formatted revenue column, revenue table. We export it, put it into Excel, or send the CSV to whoever needs it. Okay. So that's the query. There's a lot going on here. So spend your time with it, go through each step. And as I said, what you want to do is you want to start with the table that seems the simplest. Just get all the data and keep adding in, keep embellishing the query step by step to cover all the requirements, and maybe also just make it look good. So that's all about aggregation and mapping functions and arithmetic operators and dates. So let's talk about combining tables using joins. A join clause is used to combine rows from two or more tables based on a related column between them. So here, for example, you have table 1, which has 3 columns, and you have table 2, which also has 3 columns. And one of the columns, let's say this is some sort of a shared column. So one of the columns is related and has the same or similar set of values. So table 1 has 1, 2, and table 2 has 1, 3, 4. So what you can do is you can combine the two tables such that you have this one column, and then for this row 1 and then these two values, you also get the information from this table, these two values, and that creates like a one big row. So you can think of this like the result of the join. So for the column, for the value 1, we get the information from table 1 and we get the information from table 2. For the row with the value 2, we get the information from table 1 here, and there's no information in table 2. So now what happens here, whether we put empty values or we don't show this row, depends on the kind of join. So if it is an outer join, then we just show empty values here for these columns from table 2. And then here there are no more values left in table 1. So we go through table 2, we pick these values and we just show empty values here. So we show empty values for 3 for these two columns from table 1. And for the columns from table 2, we show these values. And finally, we have 4, for which we again show empty values from table 1. And we show these two values here for table 2. Okay, so that's outer join. And then we have inner join, which picks just the intersection of the values. And then we have the left join and right join. So let's maybe look at some examples and this will become a lot clearer. The first thing we'll talk about is the inner join, and this is the default join in MySQL. So whenever you type join, whenever you're trying to join two tables on a certain column, then by default, it is going to be an inner join. And let's see it in the context of a problem and it'll make more sense. Show the 10 most recent payments with customer details. So name and phone number. Okay. So let's go select star from payments. These are all the payments that have been made. Now the trouble here is that in this result, we only have the customer number. What we'd like to show is the customer details as well. Who is this customer number 471? And we will look at the most recent payments. So let me just grab the most recent payments. Order by payment date, or maybe let's do that part at the end. Maybe first let's get the customer details. So we have select star from payments and we want to show customer details, name and phone number. How do we do that? I know that there is a customer number field in the customers table as well. So if I do select star from customers, there is a customer number table. There's a customer number field or column. So what I really want to do is I want to fetch the information for customer number 471 from the customer table. How do I do that? I type select star from payments join customer number. Okay, so what did we just do? We said that I want to get some information from the customer number table as well. But how do I decide which rows are connected? Well, I want to use the customer number, right? So by default, SQL doesn't guess. SQL requires you to provide how you want to match up the rows of the two different tables. So you say join on which column you want to join, and then you provide the column from this table and the column from this table. So you say payments join customer number on payments dot. So now because there are two tables involved, so that's why you have to specify the table name before you specify the column name. So payments dot customer number equals customers dot customer number. Okay, so let's just try and make sense of this, and maybe let's put this on different lines. So we are saying that I'm not happy with the information that I have from the payments table. I also want to get information from the customer table. I want to augment some information here for the customer using the customer table. And how do I want to augment that information? I want SQL, my database server, to look at the customer number field in the payment table here. So for this row, look at the customer number field and find the row in the customers table which has the same customer number. So find the row which has the customer number 471, get all the information from that row and add it to this row. Okay. Similarly, we want the server to look at the second row and see that we have customer number 299 here. Find the row in the customers table which has the customer number set to 299. So because we're comparing the customer number columns, get all the information from that row and add it here. And let's run that. Okay, did that lead to an error? Let me just check this. Maybe I have a typo here somewhere, but yeah. Sorry, I think I had a typo there. But yeah, just to repeat, select star from payments, join customers. So we want to join payments with customers on the column customer number. And now what SQL is doing is it looks at a row in payments. It sees a customer number there. And when it sees a customer number from the payments column, it looks for a row within the customers table with the same customer number. So this customer number comes from payments and this customer number comes from customers. And then it takes all the information for that row and it adds it to this row. So now we have not just the payment information, but we also have the customer information attached with each payment. So that is join. Okay. Now we probably don't want all the rows here. So that's why we may want to just select some rows. So I'm just going to select check number, payment date, amount, customer number, customer name, and the phone number. So I just keep the check number, payment date, amount, and I just want to keep one of these columns because these columns are a bit ambiguous. They come from both. So I'll just keep customers.customer number, which I know is going to be equal to payments.customer numbers. And then I'm just going to keep the customer name and phone number. Okay. So now we have check number, payment date, amount, customer number, customer name, phone number. And then we can now cover the additional criteria, which is we want to show just the 10 most recent payments. So we want to order by payment date, descending, and limit it to 10. Okay. So now we have just 10 now we have just 10 payments, the 10 most recent payments, and you can verify this, that these are the most recent payments, 609, 603, 525, and so on. And then we have the amount, customer number, customer name, and the phone number. Okay. Now the key thing for you to understand here is the join, how it works. It looks at payments, looks at the value of customer number, and it picks a row from customer number which matches it. Okay. And this is an inner join. What does that mean? Well, there are several customers who may not have made a payment in the last 10 days, or who may not have made a payment at all. So if I remove this for a moment, order by, etc. There are several customers who may not have made any payments. So I probably don't want to show the information for those customers who have not made any payments, right? Now, if I do this inner join here, or if I do this normal, this is the inner join, I can also type inner. Then what I'm telling SQL is, don't show me customers for which I don't have any payment information. But if I change this to outer join, now we are telling SQL, okay, maybe it's like a full outer join. All right, we look up the syntax, but if we change this to a outer join, then we would get information for all the customers, right? So we would not only get information for customers who have made payments, but we would also get information for customers who have not made payments. And what is going to be present in the check number, payment date, and amount columns? Empty. It's just going to be empty. So just going back here, if table 1 is payments and table 2 is customers, then when you do an inner join, we only look at those rows where these values are present in both the columns. For example, if customer number 1 and 2 occur in payments and customer number 1, 3, and 4 occur in customers, then we will only pick 1 because that's the common column. And that's what happens when you do an inner join. It just picks the common values. On the other hand, if you do an outer join, then we're going to have a row for customer 1. We're going to have a row for customer 2. These two are in payments. And we are going to have a row for customer 3 and 4, which don't really show up in the customers column, in the payments table at all. So this is what it's going to be. And there is just going to be empty data here. Okay. Then there is the left join and right join. So we'll look at these in a second too. Okay. But before we look at left, right, and outer joins, here are a couple of exercises for you. Show the full office address and phone number for each employee. So once again, you can guess what this will look like. You will say select star from employees. And of course, now you want the full office data. So you have an office code here. So you want to do join with offices on employees dot office code equals offices dot office code. And maybe let's just put the employee number here. Yeah, let's just put employee number, and let's put maybe the last name, first name, and offices dot address. Let's just put city right now, so offices dot city. So now you have employee number, last name, first name. Let's maybe also put office code. So offices dot office code. Okay, so now we have employee number, last name, first name, office code, city is San Francisco. And then we also want to show the full phone number. So office has a phone number. So office has a phone. Let's check what that is. Select star from. So office has a phone. So we want to show the offices.phone information as well. So now we have the phone, and then every employee has an extension. So we can get the ext column from employee. That is the extension. Let's just check that. Select star from employees. extension. So every employee has an extension. So now we have employee number, last name, first name, office code. We have the phone number. We have the office city, and we have this extension. We can combine these two. So we can say concat. Let's get that here. So we can say concat, and we can concatenate the office phone with the extension. So now we are concatenating one column from the offices table and one column from the employee table, and put those together, and let's just call that employee phone number or employee phone. Okay, so now we have the employee number, last name, first name, office code, and employee phone number. Maybe let's just put that here. Okay. So now we have employee number, last name, first name, and then we have the employee phone number, which is a combination of the phone number from office and the extension from the employee table. And then we have the office code and office city. And we've been able to do this because we've done a join between employees and offices. Okay. And that's what this looks like. Here's another example. Show the full order information and product details for the order number 10100. So here you would have to look up the order details or the order details table, and then from the order details table you would have to join it with the orders table to get information about orders, and you would have to join it with the product table to get information about the product, and then you would simply have to select the data for a specific order number. So here you are doing two joins, or you're joining three tables. So I'll let you figure that out. It's not too difficult. It is just one more step removed from what we've done. So that's basic joins, and specifically that's inner joins. Now let's talk about left join, right join, and full joins. Unfortunately, in this data set, there's not enough of an opportunity to demonstrate all three. So we're just going to look at some examples online, and specifically I recommend W3 schools. If you're just looking at some SQL syntax or need some help with SQL, they have pretty good documentation on all of these. So let's talk about left join. Okay, so here's how left join works. You can look at this table and look at this picture and try to understand what's happening. But we have a demo database here. So we have this customers table, and in the customers table we have a customer ID 123. And then we have a customer name, contact name, etc. And then we have an orders table. So the customers table will be on the left. The customers table will be on the left, and the orders table will be on the right. And what we want to do is we want to join customers table with the orders table on the customer ID column. So we say select customers.customer name, orders.order ID. So we want to look at, for each customer, what are all the orders they've placed, right? So we want to see customer name and we want to see the order ID from the customers table, left joined on orders on customers.customer ID equals order.customer ID. So we want to just combine on the customer ID column, and we want to order by the customer name. So let's run this on, you can actually run this online and check. So here's our database. We have 3 customers and then we have 3 orders. Of course, and okay, actually there's more than that. There are a bunch of customers and a bunch of orders. So let's just run this and let's see the result. Okay, in our database we have 91 customers and we have 518 orders, and not every customer has placed an order. So when we do a left join between customers and orders, here's what we get. We get a customer name and then we get the order ID. So it turns out that Alfred F hasn't created any orders, so that's why we have null here. And similarly, this person hasn't created any orders, that's why we have a null here. So for every customer and every order we could find, for every customer and order combination we could find where the orders customer ID matched with the customer's customer ID, we have created a row And because this is a left join, wherever there were certain customers for whom there were no orders, there is still a single row that has been kept. So Alfred has not ordered, but we still have this null here. Now, if we did not have this left join, if we just had join here, and let's run that, you would see that now you no longer have those null columns. So now you no longer have a customer name. So if a customer does not have a matching order, so if a customer row does not have a matching order row, then that will be skipped. If you're doing a left join, you are telling SQL that you want to keep all the rows from the left table, which is the customers table. And you don't care about all the rows from the order table, but you do care about all the rows from the customers table. So even if there is no matching row from the orders table, just show that customer name and then show a null there. Okay. So that's left join. Then maybe let's look at right join. So here's an example of right join. Here we have orders. So we have one table of orders, and then we have one table of employees. Okay. Now, for every order that is placed by a customer, there is also an employee that is assigned. And then we have a table where we have details of employees. So let's say we want to get for each order the names of employees who is assigned to that order. And let's check it out. So this time we are saying select orders.orderID and employee last name, employee first name from orders. And we are saying right join with employees. So let's run that and let's see what happens. We are matching on the employee ID column. So we get the order ID. And we are also keeping the employee last name and first name. So for every order ID, we get the last name and first name of an employee. But of course, there are certain employees who may not have been assigned any orders. Maybe certain employees just don't deal with orders. They're managed people. Because we have done a right join, we are telling SQL that you don't want to miss any rows from the right table, from the employees table. So you want to show employees even if they do not have any matching order columns. So now Adam West does not have any orders, but we're still showing it here. We're just showing a empty or null value here. Instead, of course, if we did not have right join here, then you can see okay, let's just do an inner join here. Yeah, if we just did an inner join, which means we did not do a right join, if we just did an inner join here, then we would only get those employee names who have valid orders, right? So just try to remember this picture where inner join means that the row that value must exist in both columns, in both tables. Left join means that all the values that exist in the left table show up. Right join means all the values that exist in the right table show up. An outer join, a full outer join, tells you that you want to maintain all the rows from the left table. You want to maintain all the rows from the right table as well. And you want to fill in nulls wherever possible. So here's an example. We have a customers table and then we have an orders table. And I believe we're doing a full outer join on customers and orders. And this time you will see that there are certain order ID table, certain order IDs that may be null, and sometimes a certain customer name may be null, right? So that's how an outer join works. So just keep this picture in mind. This one. Outer join means you want to retain all the values. Inner join means you want to retain just the intersection of the common values. Left join means you want to retain all the values from the left table. Right join means you want to retain all the values from the right table. Okay. And one last thing, a table can also be joined with itself. You don't have to do a join between multiple tables. And each instance of the table can be given a temporary alias. So you need to rename those tables, because otherwise, if you're just joining a table with itself, it may get confusing when you're explaining which columns to join on. So here's an example. Remember employees have this reports to field, which refers to another employee. So let's say we want to show a list of employees with the name and employee number of their manager. So let's do select star from employees. Okay, so now we have all this information. We have employee number, employee last name, employee first name, and then a bunch of information. And then we have this thing called reports to. So every employee, or most employees, except the president, I believe, most employees report to another employee. So now if we want to show who they report to, we want to get information about who they report to, what do we do? Well, first, let me just simplify this output a little bit. Let me just put in employee number, and let me put in last name and first name and reports to, so that we just have this information that we really need. Okay, now I want to take the reports to number and get information from the employee table and insert that information here as new rows. So we say from employees join employees, but of course, and this is an inner join, of course, by default. So first let's do an inner join, and then we'll see if this needs to be a different join. So we say employees join employees, and now this can get confusing because both of these are called employees. So let's call one of these E. So you just give a space and then type a temporary name. You don't put as here, you just put a space. And let's call this M. So E for employees and M for manager. Okay, so now we are joining. And how are we joining? We want to join. Now this gets interesting here. From E, from the left table, we want to look at reports to. And from the right table, M, we want to look at the employee number. Okay, so from the employees table, we want to take the reports to information, and we want to find the corresponding column where the employee number matches this reports to number. Okay, so think of employees and managers as different tables. They are the same table, but think of them conceptually as different tables. We capture this number and we get that information from the M table. So that's why we have reports to equals employee number. And let's grab some information here from the other side as well. So from M, let's grab the first name, and let's just call that manager first name. And from M, let us grab the last name as well. M dot last name, and let's call that manager last name. And from M, let's also grab the employee number. Well, actually we have that already. We have reports to. So that's that. There we go. So we have select employee number, first name, reports to, and we want to select, okay, now reports to, let's just put in E dot because this is going to get confusing otherwise for SQL. And we want to select M dot first name, and we want to select M dot last name as manager last name from the employees table. I think I may have a typo here. Let me just grab this. Okay, I think I may have a typo here, so I'm just going to fix this right now. But yeah, so we have E dot employee number, and we have E dot first name, and we have, I see what the issue was. Because we have all these columns in each of the tables, so we just need to add E dot. So we say we have an employees table joined with the employees table. One is called E, one is called M. So we have E dot employee number, E dot last name, E dot first name, reports to, M dot first name, M dot last name, from employees join employees on the reports to column joined with the employee number column. Okay. So this is probably the most confusing part of it all. So now for every single employee who has a manager, because this is an inner join, remember. So for every single employee who has a manager, we get their manager information as well. So we get the name and last name of their manager. Maybe we can concatenate this. So let's maybe just do concat m.first name and m.last name as manager name. So now we have this information about each employee. We have their last name, first name, employee number, and then we have the employee number they report to, and we have the name of their manager. Let's just add a space here as well. Okay. Now one last thing here that we would want to just cover is there is a certain employee, the president, who does not report to anyone. And we have not shown that information here because we are doing an inner join. So because the president, Diane Murphy, does not report to anybody, so that row gets skipped. But instead, if we do a left join, what we're telling SQL is we want to maintain the list of all the employees from the left table E, even if they do not have a person that they report to. So now if you check, you have an employee number 1002, Murphy Diane, and for them reports to is null, and of course null value doesn't show up in the other table, so their manager name is also null. Okay, so now you see that this is supposed to be a left join, and why this is supposed to be a left join and not an inner join, because you want to show all the employee numbers even if they don't have a manager. Now suppose instead of a left join you had done a right join. What would happen now? So now we're telling SQL that only show me employees from the left table who have a manager, but on the other side, on the right side, if there are certain employees in the M table which do not feature in the reports to column, you should still show them. So let me run that and let me show you the result. So it seems like the result hasn't changed. So one thing that has happened is Diane Murphy has gone away. But if I scroll down here, you will see that now I have Leslie Jennings, Leslie Thompson, Julie Ferrelli, all these people who do not have any reportees still show up. This is because we are doing a right join. We are saying that every row from the M table should be represented, even if they don't have any matching information in the E table. So that's the issue with the right join. And if we did a full outer join, or I think it's just called an outer join. Okay, I'm not sure what the outer join in MySQL is. I guess it's just called full outer join. Okay, I think I'll have to look it up, but if we did the full outer join, then we would see this, we would see Diane Murphy, and we would also see all this information. Pamela Castillo, Larry Bolt, etc. Okay, we'll check this out. How do you create a outer join in MySQL? Okay, never mind. So that's joins, and here are some exercises for you to try out to become familiar with SQL joins. Report the account representative for each customer. Report the total payments for the Atelier graphic. This is one of the, I think this is one of the customers. Report the total payments by date. Report the products that have not been sold ever. List the amount paid by each customer, and so on. So each of these will require a certain join. Not all of them may require joins, and for some of these it's possible that you can do them without joins. In some cases you will also have to do some other things like arithmetic operations, etc. For example, list the names of products sold at less than 80% of the MSRP. There are two ways to improve query performance in MySQL, especially when you're working with really large datasets. One is to create an index. Now, if you often search or order data by a particular column that's not a primary key, then you can add an index to make the query performance faster. For example, if you search by customer's last name a lot, or if you order by customer's last name a lot, then you should do this. You should run this command, create index customer last name, and give it whatever name you want. So you say create index so-and-so on the table customers using the column contact last name. So if we do this, if we just run create index customer last name index on customers, what we're telling SQL is that we want SQL to track the contact last name information, the contact last name column in the customers table, and set up a way for us to efficiently do queries on that column. So what does this mean? Well, the next time we do a query on the last name, let's say we do something like this, select star from customers where contact last name equals Lee. Because contact last name has an index, this query will be very fast. If the contact last name did not have an index, then this query would be fairly slow. And the difference would be if the contact last name did not have an index, then SQL would have to search through all the rows. But if the contact last name does have an index, then SQL can actually avoid searching because it has set up some ways to efficiently track information and search information from the contact last name column. In fact, it is using a data structure called a B tree, and you can see what kind of index is created or what kind of indexes you have on a table simply by typing show index from table name. So you can see that we have a primary key which is tracked using an index because typically you extract information using primary key. We have a foreign key, so every foreign key also creates an index. But then we also have this customer last name index which we just created. And this index is represented as a B tree, which is a data structure, an efficient data structure optimized for querying. So whenever you query by last name, that is very efficient. Not only querying, but ordering by last name is also efficient. So you could do something like this, select star from customers, order by contact last name, limit 10. Again, if you have an index, this is going to be fairly efficient. If you don't have an index, it's going to be slow. It's not going to make a difference for this database that we are working with right now. But when you have a really large data set, a really large database with millions of rows, then this will start to make more sense. So if you are doing some queries and those queries seem to be taking a long time, maybe consider creating an index, or maybe consider asking the database administrator to create indexes on the columns that you are ordering by or searching by most frequently. Okay. And indexes can also be created on multiple columns if you put conditions on multiple columns frequently. So you can check that out. Then another thing that you can do is create something called a view. So if you perform a query, or if you perform a query very often, or if you very frequently join tables for querying, then you can create a virtual table out of that query. And this virtual table is called a view. So here is how a view is created. So we'll see how a view is created and how it's used, and then you'll probably see more, learn more about how it works. So to create a view, you say create view USA customers as, you type the name of the view and you type as, and then you type a query like you normally do. So instead of doing select star from customers where country equals USA, so this is the information about all the American customers. What we want to do is we want to take this query and we want to give it a name, USA customers. So let's say create view USA customers, and that is now going to represent this query, the word USA customers. How do we use it? We use it just like a normal table. Now let's say we want to get just the customers who are in California. So we can do this, select star from USA customers. So now we refer to this view which we have created already. It's saved in the database, that view. So select star from USA customers who are from the USA, where state equals CA. And when we run this, you can now see that we only have customers from USA. Of course, that's because the state is CA, but you can see that USA customers actually used information from this query that we had defined earlier. Okay. So conceptually what's happening is wherever the SQL server sees USA customers, it's simply going to replace this with this. Select star from customers where country equals USA. And in fact, you can also run this. Okay, this is not going to work directly. But yeah, you need, once you create a view and use the view, so SQL is going to replace the view name with the actual query that you have provided. Now, typically, when you create a view, no new data gets created. It's simply that information that is tracked, which query a view represents. But certain relational databases also support creation of materialized views. So let's say you're doing joins between certain tables very often, and then you're getting information about that from that joined table, from that joined query. Then you can create a materialized view which is going to contain the joined version of the two tables, so that whenever any of those two tables is updated, the view gets recreated, and that is like a separate table that is always tracking the latest version of the joins of the two tables. And that takes up more space, but that makes it very efficient to query. So now whenever you make queries on that view, instead of rerunning the query that creates the view, it will have the view already as a table saved within the database, and all that information will be cached, so you can get the result out of the view very easily. Okay, so right now by default we are not actually creating a table USA customers, but if you make this a materialized view, then the database is actually going to set up this table called USA customers somewhere, and that is going to be kept up to date with the list of customers from the USA. Okay, so that's materialized views, not something you'll have to worry about or work with often, but in case you come across the term, that's what it means. Let's talk about executing SQL queries using Python. One way we've seen how to execute SQL queries is using the MySQL command line interface. Another way we've seen how to execute SQL queries is using the MySQL workbench. And the common thread here is all you need is to connect to your SQL server, your database server. That could be running locally, that could be running on the cloud. And once you have connected to that server, you need to be able to send instructions to the server, the queries that you want to send, that you want to perform, and then the database server is going to give you back the results, and you should be able to understand the results. So this is something that you can do from any language. Every language has some libraries for working with SQL relational databases. In Python, one of the most popular libraries is the SQL Alchemy library. So you can look it up. This is SQL Alchemy or SQL Alchemy, and it's a very powerful toolkit for Python that pretty much everybody who uses SQL databases and does some programming in Python uses this library. In fact, we use it on Jovian. When you open your profile page to get the information for your profile, we use the SQL Alchemy library to get information out of a MySQL database, and then we display that information to you on the profile page. Okay, so it's a very powerful and a very efficient library as well. It's as it says here, it provides enterprise level persistent patterns designed for efficient and high performing database access, adapted into a simple Pythonic domain language. Okay, so that's the library we are going to use. Now, here's the other thing. There is not just a single relational database, there are many. In fact, here are some. So MySQL is one that we've looked at. Apart from that, there is something called Postgres. So this is sort of a slightly more advanced version of MySQL, where it also supports latitudes and longitudes. It also supports like a JSON column type. It has more column types. Then there is something called SQLite. So SQLite is a limited version of MySQL, and SQLite is typically used for situations where you possibly cannot set up an entire server, and you just have to maybe work with something very light. So SQLite, instead of setting up a proper database server, etc., simply uses a file on the disk, and that file just works as the database. Of course, everybody uses the disk, but SQLite just makes it very efficient and very fast and very small. So typically this is used in, let's say in your phones. So any Android app or any iOS app that you use if it stores any information on your device, typically that information will be stored in a SQLite database, because it has very low memory and CPU requirements. Of course, it does not implement the entire SQL language. It only implements parts of it, and it sort of cuts corners here and there to make it possible to use SQL in a very low memory setting. In fact, in your assignment, you will be using SQLite, so that is something that can run easily on Binder. Setting up MySQL on Binder is a big challenge, so we're just going to use SQLite. Apart from that, you have some proprietary databases like Oracle. So Oracle has its own database. Again, that has its own flavor of SQL. Then you have the Microsoft SQL Server. So that has, again, its own version of SQL. There are some changes. Not all the commands work exactly the same way. And in fact, if you look up any SQL tutorial, they will tell you what the differences between the different flavors of SQL are. Right? For example, W3 Schools is the one that I would recommend. And here on the side, you can see all the possible different things that you can do with SQL. And if you open any specific example here, like alter table, you will see how these are different across different SQL databases. So alter table, which is to change the column name, etc. This is how it works on SQL Server. This is how it works on MySQL. This is how it works on Oracle. In this case, I think they look the same. There's no change here, but there are other things probably with constraints where things would be different. Yeah, so you see here, this is how it works with SQL Server. This is how it works with MySQL. So if you're putting some sort of a unique constraint in SQL Server, you put it here. In MySQL, you put it at the end, and so on. So just look things up. Don't worry about knowing all the different variants of SQL. But the way it is relevant for us here is SQL Alchemy does not include all of these connectors to all of the different types of relational databases. So what you'll have to do is maybe you'll have to use some kind of a connector, a connecting library. So for example, if you're connecting to MySQL, then MySQL Python is a commonly used connector. So you will have to either use MySQL Python, or there's another connector called PyMySQL. So there are several connectors for MySQL, right? So SQL Alchemy gives us the Python interface for writing SQL queries, and then internally it uses one of these libraries to connect to the specific kind of database that you want to work with. So you'll need to install both. So now we are going to install SQL Alchemy, and we are going to install PyMySQL. So let's install both of them. SQL Alchemy handles the Python side, PyMySQL handles the MySQL side. And I'm just going to clear output here. And let's import. So here's how you connect to a SQL database. The first thing you do is you say from SQL Alchemy import create engine. So you import create engine, and create engine takes a string, a connection string. So what you do is you say create engine, and then you give it this string, this database connection string, which contains all the information required to connect to the database. Now remember MySQL Workbench. Here, when we try to connect to a new database, we would have to provide a host name, we would have to provide a port, we would have to provide a username and a password. So it works exactly the same way here. We say what kind of database we want to connect to. So we want to connect to a MySQL database. So that's why we have MySQL here. We say what connector we are using. Now, even for MySQL, there are several connectors that people have written for SQL Alchemy. So we are using the PyMySQL connector. If we were using the MySQL Python connector, then this value would be different. But in any case, we want to use the MySQL database. So this is the kind of database that we are using. Plus, this is the kind of connector we are using, PyMySQL. Then we say : and this is just the standard syntax. Then we provide the username, And after the username, you provide the password. So normally you shouldn't type passwords out, but let's say if you wanted to provide the password directly, you would say username colon password. Then you type @ and then you type the server. So the host name that you put here, 127.0.0.1, which means the local computer. This is just short for the local computer, is a standard host name. And that is also known as localhost. So this could be 127.0.0.1 or this could be localhost. Both of those mean connect to a database on this computer. But if you are connecting to a database somewhere on the cloud, then you should get the username and the password and the host name for that cloud database. Next, you provide the port. So for every database, there is a certain port that you connect at. 3306 is the default port that is used in most databases. But if there is a different port, then you can ask your database admin to give you the port. So once again, you get the type of database that you're connecting to, the type of connector you're using, :// the username, password, @ localhost, the port, / the name of the database that you're connecting to. Okay. This is not something you have to remember. You can always just look up SQL Alchemy connection string. And let's say you want to look it up for SQL Server. So you can just search connection string for SQL Server. And you can see what that connection string will look like. So for SQL Server, this is what it will look like. MS SQL plus PYODBC. So the PYODBC is the connector. And then username, password, @server. So server would be localhost :3306 or some other online server /database. Okay. Now, one thing I've done here is instead of putting the password, I don't want to type my password into a Jupyter notebook. So I have just imported getPass and I'm going to run getPass. I'm going to type the password here. So now the variable password contains the value of the password that I just typed in, but I'm not going to display it in front of you because I don't want you to see my password. So what I'm then going to do is use string formatting to insert the password into this string. So now I have the connection string inside which I have this gap using these quotations, using these brackets, and then I'm calling .format password, and that's going to put the password into that gap. Okay. So never put your password directly into your Jupyter notebook, especially at work, because that's going to be very bad, because then anybody who has your Jupyter notebook will be able to use your account. Always use getPass. So just put the password into a variable and then pass that variable using string formatting into the connection string, and that then creates this engine. Okay. So now we've created this engine. So what has happened so far? Nothing really. We've just set up this object and we've given all this information to SQL Alchemy. Then we actually connect to the engine. We say with engine.connect as conn, CONN. And then we can execute SQL queries. Okay. So we connect to the engine as conn. And why do we have this with? Well, this automatically takes care of closing the connection once we get the result. So we say conn.execute, and now I'm connecting to my local database. So make sure that if you're running this on your computer, you have the SQL server, MySQL server running. And if you're running this on Binder, obviously it's not going to be able to connect to your local computer. So make sure that you're running this locally on your computer. Okay. So now we say connection.execute and we have a query. So we have select office code, city, phone from offices. So let's see what this query gives us in the SQL workbench. Okay, maybe first I should do use database classic models, or just use classic models. Yep. And now I can select office code, city, phone number. So I expect to see information like this. 7 office codes and then the city and phone number. So I get the result from conn.execute, and let's look at the result. The result is this legacy cursor result. It doesn't give me much, but you can convert that result into a list So you just call list on it, and that gives you this list of offices or list of results. And let's check that. So here now you get 1 San Francisco plus 1650219, 2 Boston plus 1215, and you can match that information up here. Okay. So quick recap: install SQL Alchemy, install the connector, import create engine, then create the engine using this connection string, which contains information about the kind of server, the kind of database you're using, the kind of connector you're using, the username, password, host name and port, and database name. Of course, don't type your password directly, get it using getPass. Once the engine is created, connect like this and then get the result. And now you have this result here. So now once you have this result, this is a Python list and it's a list of tuples. The idea I want you to take away is that you can create this engine, create a connection, and then get data out of a SQL database using Python. Now, of course, this is a lot of work, and that is where you have this nice, neat little library called IPython SQL. It's probably one of the most wonderful libraries I've come across because it takes away so much of the complexity that you have to take care of when you're connecting to SQL databases. So the IPython SQL library provides something called magic commands to write raw SQL queries in Jupyter. So you just type a SQL query within Jupyter, and that will execute and that will get you the results, and it'll give you the results in a nice tabular format, something that you can use within Python. And in fact, it uses SQL Alchemy under the hood. So you want to have SQL Alchemy installed, and you want to have the right connector installed. So for example, in this case, I'm using PyMySQL. So I have SQL Alchemy installed, I have PyMySQL installed, and now I'm going to install IPython SQL. So I install the IPython SQL library, and now it really is magic because, and these are called magic commands. The first thing you do is you have to load this extension within the Jupyter notebook. So you say load ext. So you type this percentage symbol, you type load ext, and then the extension that we're loading in is called SQL. And once you type this, once you run this cell, load ext SQL, then you will be able to start using this new command called SQL. So anything that starts with a percentage is called a magic command in Jupyter. This is no longer plain Python. Now this is some instruction that we are sending to Jupyter. So here's what you can do. You can type percentage SQL. Okay. And then you give it a connection string. So for example, if you give it MySQL plus PyMySQL :/ root : and then you put in the password here. Let's say the password is just password at localhost :3306 and / classic models. Okay. And I'm just going to reveal my password here for a second. So I'm just going to, the password is, well, it's Akash123. So if I run this, classic models, yeah. So if I run this, now I'm connected to the database, right? I've just typed MySQL plus PyMySQL : root, so username / password. So this is a SQL Alchemy connection string. Now instead of having to do import engine, create engine, etc., I can just type :SQL, give it the connection string, and that is just going to connect to the database. Now what to do if I don't want to reveal my password? I would do from getPass import getPass, and then I would run getPass, and okay, maybe I should put the result into password. Okay, and then I type my password. So now this variable password has my password, and then I can take this and just put it into a string. So I create a normal connections str, I create a normal Python variable, and I just insert the password here. So I do dot format password, and now I've created this connection string. So now I want to, instead of typing out the full connection string, I want to pass the variable connection string. And we do that by, in magic commands, we pass value from variables using these brackets. Okay, so when we type this, when Jupyter sees this bracket, it says, okay, let me take the value of connection str, which is all of this, with the password replaced here, and let me replace this with that value. With all of this stuff. Okay. So this is all a roundabout way of hiding my password. But in any case, the point being, you just provide the connection string. Either you type out the entire string, including your password, or you put the connection string into a variable and you pass it using this bracket. But just with this one line of code, we are now connected to the database. And we can now execute queries. And here's how you execute queries. You type %SQL, and then you just type the query, like select office code, city, phone from offices. So there you go. So now you can see that it's telling me that I'm connected on using this connection root and it hides the password, thankfully. So we've typed this query, and here is the result of the query. So the result is office code, city, phone, 1, 2, 3, 4, 5, 6, 7, San Francisco, Boston, etc., and the phone numbers. If you have a multi-line query, something that you need to split across multiple lines, then just put a double %. And when you put a double %, then this entire cell is passed to this magic command. When you put a single %, that just works for a line. The double % works for an entire cell. So let's run that. So now here we are doing the same thing. Remember, for every year and every month, we want to get the total payments. So that's what we have here, year, month, total payments as a result of this complex SQL query, %SQL, and then you type the name, then you type the query, and that's the data. Here's when it gets even more interesting. You can actually combine Python code and SQL code. So here's what I'm doing. I'm saying earnings result equals, and then from this point on, once I type %SQL, Jupyter detects that this is a magic command, and it's going to read all of this as SQL code. Okay. So what's happening is that all of this is being passed into this magic command %SQL, and that magic command is going to, under the hood, use SQL Alchemy, create a connection using the connection string that we had set up, and pass this SQL query to that connection, and from that connection get some results, and then take those results and convert that into this format. Okay. And then that data frame kind of format is going to be put into this variable earnings result. So you type the variable name, you type equals, and then you type %SQL, and then you simply type the query. And now you have earnings result. That was the topic for today. As I've said, W3 Schools is a good resource, and I would just go through all of these just to get a sense of everything SQL has to offer, and use this notebook to learn how all of these things fit together. So we looked at aggregation, grouping, pagination in SQL queries. We looked at mapping functions, arithmetic, and working with dates. We looked at how to combine data from different tables using SQL joins. We looked at improving query performance with indexes and queues. We looked at how to use Python to execute SQL queries, which is to get SQL Alchemy, get a connector, create a connection string, put the password into it securely, create an engine, runs queries, or we could just use the IPython SQL magic commands and simply use direct raw SQL statements inside a Jupyter notebook. So what should you do next? You should definitely check out some of these other challenges on the Classic Models database. This is from this professor. His name is Richard T. Watson. It's a great database, and he has also given you a lot of questions to solve. So there are about 100 or 120 questions that you could try and solve. So it's all about exercise, SQL. There's no other way to become an expert at SQL. And I wouldn't say I am, because I haven't done enough exercises. Here's one more set. A different database that you should look at is the Database System Concepts book. On this book page on dbbook.com, you have a bunch of exercises. So you can check here, sample lab exercises and term projects. So here you can figure out there is a basic SQL file, just like the Classic Models database. And there are a bunch of exercises, like here are some advanced SQL exercises. And this is all based on a university database. So here you have all these questions. The university allows an F grade to be overridden by any pass grade. Create a view that lists information about all fail grades that have not been overridden. And the view should contain all attributes from all the takes from the takes relation, right? So there's a lot going on here. And of course, this is more advanced. And then you have some more basic and intermediate questions as well, right? So these are two good databases, the classic models database and then the student university database. You also have solutions for the classic models database. So if you want to check out solutions, this person has very kindly put up their solutions. So you can look up the solutions to the different challenges here. Yeah, so these are some of the solutions for the classic models database. Try that out. Then you have these interview questions with SQL. This is this repository has been created by Alexei Grigorev. He actually did a webinar recently, a few weeks ago with us, webinar on machine learning. But he has created this repository called Data Science Interviews. And specifically in this repository, you have under technical questions, under technical.md, you have SQL. So just check out SQL. And here you have a bunch of questions. I think probably over 50 or 60 questions, right? And you can see some of these get pretty big, but the concepts are the same. You see select, order by, join, and then you're taking the result of one query and then using that as a table in another query and so on. Okay, so that's SQL for you. Yeah, I think there are about, 11 questions here, but they cover a lot of different use cases. Then W3 Schools is a great place to learn. SQL Alchemy is, again, if you want to learn more about SQL Alchemy, the object relationship mapping, here's one tutorial that I found and went through. It seemed good. Otherwise, reading the official documentation is always the best way and the most comprehensive resource. I wouldn't worry too much about this right now. As long as you can just connect to databases and make some queries, you should be fine. And finally, if you really want to get a book, then this is the book I would recommend. This is the book. So one of the authors is the professor who I learned SQL under. He was my college professor. But yeah, this book overall is still great. And even if you don't want to get the book, I would definitely check out the slides. Whenever you want to get deeper into SQL, I would definitely encourage you to check out the slides on this book for sure.
Hello everyone, this is Samanvita and welcome to the series Solving SQL Interview Questions. In this series, we'll be covering 4 SQL interview questions that were asked at Amazon, Netflix, Uber and Google. Before we go ahead and start solving these SQL interview questions, there's something that I'd like to introduce you to first, and that is 3-step approach for solving any SQL interview questions. Generally, in an interview, you're not always expected to give the correct answer, but the interviewer would like to know what is the approach that you have tried for solving a particular problem. And this is where our 3-step approach might help you. Step 1 of our approach is understanding the inputs and the outputs. Do not jump into solving the query as soon as you see the question. Understand what are the inputs that you should be using and what are the outputs that your final result should be containing. Step 2, articulate your solution verbally. Once you've decided what are the inputs and the outputs, explain your interviewer what is the approach verbally. Get a confirmation of your understanding and then start writing your query. Step 3, construct the query step by step. Once you've decided what are the inputs and the outputs, once you've gotten a confirmation of your approach, break down your SQL query into steps and print out the results of these intermediate queries and then improve your final result. So now that you've gotten an idea on how to approach an SQL interview question, let's go ahead and solve one. As you can see on the screen, the platform that we'll be using in the entire series for solving the interview questions is known as the Strata Scratch. And if you look at the screen, on the left side, you can see the questions and all the required information that you need to know. And on the right side, you can start writing the query. Now make sure that you're signed into stratuscrash.com before you actually run the code, or else you'll not be able to run the code. Unfortunately, you'll not be able to check whether the solution is correct or wrong, but we'll be sharing all the required links for practice and to check whether your solution is correct or wrong down in the description. So do not worry much about it. In this video, we'll be solving an SQL interview question asked at Apple. As you can see on the screen, the problem that we'll be solving today is customer details. Find the details of each customer regardless of whether the customer made an order. Output the customer's first name, last name, and the city along with the order details. You may have duplicate rows in your results due to a customer ordering several of the same items. Sort records based on the customer's first name and the order details in ascending order. As you can see, we have two tables, customers and orders. Let me just quickly have a look at all the columns that are present in both the tables. Customers table contains ID, the first name, last name, city, which we want. And the orders table contains ID, customer ID, which I believe this customer ID is the same as the ID present in the customers table, and order date and order details, which again is something that we want. According to our approach, the first step of solving an interview question is understanding the inputs and the outputs. Now, what are our inputs? Since they said find the details for each customer regardless of whether the customer made an order, I'm going to use the customer ID as one of the inputs. And they've mentioned what the output should contain, and they've mentioned that it will contain some duplicates. Now, they also said to sort records based on the customer's first name and the order details. So my inputs will also contain customer's first name and order details to perform the sorting. And the output should contain customer's first name, last name, and the city along with the order details. So these are going to be my inputs and the outputs. The second step of our approach is articulating the solution verbally to the interviewer. In our approach, we have established that the output should contain first name, last name, city, which is coming from the customers table, and it should also contain order details, which is coming from the orders table, which means we have to combine both of the table results to get the final output. And for that, I can perform a join. Now, what join do I have to perform? Given that I'm joining customers table on the orders table, I'll have to use a left join so that I'll get all the customer details present in the customers table irrespective of whether they've made an order or not. And that's what the question states. So I'll be performing a left join on the customers tables with respect to the orders table to get the final output result. Finally, they've also mentioned that we have to order it by first name and also order details. So this is going to be my approach. Now, the third step of our approach is constructing the query step by step. And the first part of our query construction is performing the join. Select, since my output should contain first name, last name, city, and the order details, these are the column names that will be present in the select statement. First name, last name, city, order details from customers, left join orders on customers.id is equal to orders.cust.id, because we have established that customer ID is the ID that is common and similar to the ID in the customers table. So let me just run this. As you can see, the left join has been performed, and whenever there is a customer who made an order, the order details value is filled, and if that customer has not made any order, that order details section is empty. Now, the second part of our query construction is ordering this by order details and the customer's first name. So I'm just going to say order by first name, comma, order details, and I'm going to run this. As you can see, this has been ordered according to the first name and then followed by the order details. So yeah, that's what they've been asking us in the question. Thank you so much for watching. Welcome to the series Solving SQL Interview Questions. In this video, we'll be solving an SQL interview question asked at LinkedIn. The problem that we are solving today is salaries differences. Write a query that calculates the difference between the highest salaries found in the marketing and engineering departments. Output just the absolute difference in salaries. And the tables that are given to us are DB employee and DB department. According to our approach, the first step of solving the SQL question is understanding the inputs and the outputs. For that, I quickly just want to have a look at all the columns that are present in these two tables so that I'll know what inputs I have to give to the table to get the salaries difference output. As you can see, it contains ID, first name, last name, salary. So since they asked us to calculate the highest difference between the salaries, I'm going to use the salary column as my input. And there's department ID. And in the DB department table, I have ID and the department. I believe this ID is similar to the department ID present in the employees table. And as they mentioned in the question, they want specifically for marketing and engineering departments. Department is going to be my other input. What is going to be my output? Output just the absolute difference in salaries. So these are my inputs and the outputs. Now the second step of our approach is articulating a solution verbally to the interviewer. As we've discussed that the columns that we'll be using are salary and the department. And what they've asked us to calculate is the highest difference of the salaries between the departments marketing and engineering. So when they're saying highest, you probably are expected to use the aggregation function max in each department and calculate the difference between them. So my approach is probably going to be, first thing, I'll perform a join between the DB employee and DB department so that I can get the department name. And the first thing I'll do is write a select statement which will get me the maximum salary from the department marketing. And I'll write another select statement which will get me the maximum salary from the department engineering. And then I'll calculate the difference between this select statement and the other select statement, get the absolute difference, and that's what they're looking for. There's also another way that you can approach this problem without having to use two select statements, and that is by using a self-join with the help of table aliases. Now, right now, we're performing a join of DB employee with DB department so that we can get the department name, right? What if we know what is the department ID of the department names marketing and engineering? We can simply just use this department ID within this table, calculate the maximum salary of that particular department and minus it with the maximum salary of the other department by performing a self-join. Now, the third step of our approach is constructing the query step by step. And the first part of our query construction is calculating the maximum salary for the departments marketing and engineering. So for that, I'm just going to say select max of salary from DB employee join with DB department on DB employee dot department ID is equal to DB department dot ID. And I'm going to give the where clause for the department so that I'll get that specific department maximum salary, where DB department is equal. Okay, sorry, I think I should say DB department dot department is equal to marketing. So let me just execute this. And as you can see, I now got the maximum salary for the department marketing. Similarly, I'll also be calculating the maximum salary of the department engineering, and then I'll get the absolute difference between these two select statements. So for that, what I'm going to do is I'm going to put this entire statement in one bracket, and I'm going to do minus, and I'm going to copy paste the same syntax here because it's almost the same thing except for the marketing name. Instead, I'm going to say engineering. So these are the two select statements, and I'm going to perform absolute difference between these select statements so that I will get the difference between the highest salaries of the departments. So I'm going to say select absolute difference of these, and I'm going to give this an alias name as salary diff, and then I'm going to execute this. As you can see, we now got the absolute highest salary difference of the departments marketing and engineering. So this is one way of our approach. As we've discussed, there's another way of approaching the same problem, which is by using a self-join. First, let me just see what are the department IDs for the department names, marketing and engineering. So I am just simply going to run this. And as you can see, engineering is having the department ID 1 and marketing is having the department ID 4. So using these numbers in the department ID column of the DB employee, I will perform a self join to calculate the highest difference. So for that, I am going to say select max of A dot salary minus max of B dot salary, and I'm going to give this as salary difference from DB employee A, and I'm performing the self join here, DB employee B using table aliases, where A dot department ID, which is equal to 1, and B dot department ID is equal to 4. 1 is for engineering and 4 is for marketing, and I'm calculating the maximum salary of the engineering and maximum salary of the marketing, and I'm performing the difference. And since they said they want the absolute difference, I'm going to say absolute of this and then run this code, and as you can see, we got the same answers. So yeah, that is how you approach these kind of SQL interview questions. Thank you so much for watching. In this video, we'll be solving an SQL interview question asked at Facebook, which is a part of Meta. Let's go ahead and start solving. As you can see on the screen, the problem that we'll be solving today is popularity percentage. Find the popularity percentage for each user on Meta/Facebook. The popularity percentage is defined as the total number of friends the user has divided by the total number of users on the platform, then converted into percentage by multiplying by 100. Output each user with their popularity percentage, order records in ascending order by user ID. The user 1 and user 2 column are pairs of friends. So according to our approach, the first step of our query construction is understanding the inputs and the outputs. Let's go ahead and take a quick look at the table, and we can see that it is user 1 and user 2, and these user 1 and user 2 columns are pairs of friends. So we have to use both user 1 and user 2 as our input columns, and the output should be each user along with their popularity percentage. Now the second step of our approach is articulating a solution verbally to the interviewer. According to our approach, they've asked us to calculate the popularity percentage, right? Which is basically total number of friends a user has divided by total number of users on the platform into 100. Before we actually multiply with 100 and get the percentage, we first need to figure out how to calculate the total number of friends a user has and also the total number of users on the platform. Before I figure out what method or function I need to use to calculate the total number of friends a user has or the total number of users, I just want to have a quick look at how the data is in the table. For that, I'm just going to come back here and say, select staff from Facebook. I'm going to run this. And as you can see, there is user 1 and user 2, where user 1, 2 is friends with user 2, 1, and 1 is friends with 3, and 4 is friends with 1. This seems to be a little confusing for me to calculate a total number of friends a user has, because seems like 1 is spread across both the columns, and I can understand that the rest of the users are also spread across like that. So for my better understanding, what I want is if I can have all the 1s on the left side and their friends on the right side, and all the 2s on the left side and their friends at the right side, it is easier for me to calculate the total number of friends a user has. And for that, the thing that comes to my head is union. So union is basically a method used for you to combine the results of two select statements and removes any duplicates present in it. So that's how union works. So that is going to be my approach for calculating the total number of friends a user has. Now the second step is calculating the total number of users. So if I'm having all the users on the left side and their friends on the right side, I can just simply say distinct of user 1, right? That should probably give me the all existing users on the platform. Now, the third step of our approach is constructing the query step by step. And the first part of our query construction is calculating the total number of friends a user has. Let me just go back to my query editor to write that query first. I already have select staff from Facebook friends. I'm going to say union user 2 as user 1, user 1 as 2. I'm going to order this by user 1 because they wanted the final result to be ordered by the user. I'm just going to run this query. As you can see, we are now having it in the format of all the 1 on the left side and its friends on the right side, all 2s on the left side and its friends on the right side. This is how that union is working, but what exactly is happening here? So when you say the first part of a query was select staff from Facebook friends, right? And this is the result. Now, the second part is we are saying use user 2 as user 1 and user 1 as user 2. So now this column will become user 1 and this column will become as user 2. So the union basically combines these two results and removes if there are any duplicates present in it. So let's just see if there are any duplicates or not. As I can see, is there any Biraj and Akash? No. And then we are saying Biraj and Himani. So there's already a Biraj and Himani here. So we can remove this. And I'm also looking at Akash and Himani. Is there any Akash and Himani somewhere here? No. So it's going to stay. And there's also something called as Himani and Biraj. There's Himani and Biraj already here. I'm just simply going to exclude this. So it is now in the format, right, on how we wanted it, which is all the users on the left side and their respective friends on the right side. Now, this explains the first part of our approach, which is calculating the total number of friends a user has. Now, all I have to do is just group it by the user 1 and do the count of the user 2 to get how many friends each user has. Now, the second step of our query construction is calculating the total number of users on the platform. So for that, what I can do is I can just simply calculate the unique entry of each user 1 in this table, right? All I have to now do is use this as the input for select distinct user 1 from this subquery. I'm going to give this table result friends. I run this. As you can see now, these are all the distinct users. Now I just have to say you can see there are a total of 9 distinct users on the platform. I just now have to divide the count of each user's number of friends by this into 100 to get the popularity percentage. But as you notice here, the total number of users on a platform is using this as the input for it to calculate the total number of users. Now for me to divide this by this, I have to store this result in something so that I can use this as the input for this to calculate the popularity percentage. So for that, I'm going to use a common table expression. With is the keyword which indicates that you're writing a common table expression, and I'm going to give this common table expression a name with friends as this. Let me just, there's a seems to be a type. I'm going to remove this. This is my common table expression, and I'm going to use this as the input for my next query, which is calculating the popularity percent. I'm going to say select user 1, which is basically they want for each user the popularity percentage. So I'm going to select user 1 and I'm going to say count of user 2, because count of user 2 is the one which will tell you the total number of friends a user has. I'm going to divide this by select count of distinct user 1 because that is the section which will give us the total number of users on the platform. And this entire data is from the friends common table expression. Group it by user 1 because we want it for each. As you can see, we now have the popularity. Now I just simply have to write this with 100. This is the popularity percentage of each user. So yeah, that is basically how you solve this popularity percentage question. Thank you so much for watching. I will see you guys next time. Bye. In this video, we'll be covering an SQL interview question asked at Uber. So let's go ahead and start solving. The problem that we'll be solving today is distance per dollar. As you can look at the screen, you're given a data set of Uber rides with the traveling distance, distance to travel column, and cost, monetary cost column for each ride. For each date, find the difference between the distance per dollar for that date and the average distance per dollar for that year month. Distance per dollar is defined as the distance traveled divided by the cost of the ride. The output should include the year, month, and the absolute average difference in the distance per dollar, absolute value to be rounded to the second decimal. You should also count both success and failed request status as the distance and the cost values are populated for all the requests. Also assume that all the dates are unique in the data set. Order your result by the earliest request date first. So this is our question. And according to our approach, the first step is understanding the inputs and the outputs. So for that, I'm just going back to the question again. And they're saying for each state, find the difference between the distance per dollar for that date and the average distance per dollar for that year month. So I see that they're asking us to calculate something called as the distance per dollar per each date. So I see that we have to use a date time column, which I know by looking at the table, it has something called as the request date. So my input is going to be request date. And for calculating the distance per dollar, I need to divide the distance traveled by the cost of the ride. So I'm going to use the columns, distance to travel and monetary cost. So my inputs are going to be these three: request date, distance to travel, and monetary cost. Now my outputs are going to be, as they explicitly mentioned in the question, the output should include year, month, and the absolute average difference in the distance per dollar and the absolute value to be rounded off 2 decimals. So now the second step of our approach is going to be articulating our solution verbally to the interviewer, which is basically explaining our approach and getting a confirmation of our understanding. So from the question, we understand that they want us to include the year and month, which means we are basically expected to extract the year and month from the date time column, which is request date. So for that, I'm going to use the date format in this way so that it will extract the year and month for me. And the second thing they want from us is the absolute average difference in the distance per dollar. So for actually calculating the difference first, you need to calculate the average, right? So I'm going to use the average window function so that it is calculated for each and every row. Then I'm going to use the absolute function so that I'll get the absolute value of the difference that I'm getting. Then I'm going to use the round with 2 as the input because they've mentioned that they want the final output to be rounded off to 2 decimals. Then finally, I'm going to group by the year and the month because they specifically said that they want the output for each year and month. And also they finally mentioned that order your results by the earliest request date first. So I'm going to order this by this date format that we are creating for year and month. So this is basically going to be my approach. Now the third step of our approach is constructing the query step by step. And the first part of our query construction is extracting the year and month out of the date time column. So I'm going to say select date format and our column name is request date. And the format that we want is year and month. And I'm going to give this entire extracted column a name, probably year, month. And I'm getting this entire data from the Uber request logs table. And since they want this for each year month, I'm going to group by year month, and I'm going to order by year month. So this is our code. I'm going to execute now. And as you can see on the screen, we can now see the output for each and every year and month. Now the next step of our query construction is calculating that difference between the average distance per dollar, which is absolute value, rounded off to 2 decimals. So for that, as we've established in our explanation, that we'll be using the average window function. So it has partition for that each year and month. So I'm going to say average distance per, okay, I think it's distance to travel divided by monetary cost. So they've mentioned in a question that the distance for calculating the distance per dollar, it is distance to travel divided by the cost. So I've given that. Now I'm going to minus this by average of distance to travel divided by monetary cost over partition by, since they want this to be partitioned by the year and month, which is our date format request date of this year month. So the reason why we are using this year month column directly instead of giving it a column name, which is year month, window function will not be able to identify this prior. So we need to specify the entire thing. So this is done. Now I'm going to give this entire column name a function, which is probably called as the average difference. So this entire thing is again coming from the Uber request logs and order by year month, group by year month. So I'm simply going to run this query now. As you can see, you now have the year month and the average difference. But in the question, they've specified that they want it explicitly as the absolute value, right? So you now have to use the absolute function, and that's what I'm going to do now. So I'm going to say absolute value of this entire thing, and I'm going to run it. As you can see, this has been rounded off to absolute value, which is basically it's returning you a positive value. Now they also want this to be rounded off to 2 decimals, so I'm now also going to use round method. So I'm going to say round, and then I'm going to come back here and say 2, and then I'm going to run the code. As you can see, now this is rounded off to 2 decimals. So that's basically what they're looking for. The output should contain the year, month, and the average difference between the distance per dollar, the absolute value rounded off to 2 decimals. So yeah, that's how you solve these kind of SQL interview questions. Thank you so much for watching. I'll see you guys next time. Bye. In this video, we'll be covering an SQL interview question asked at Amazon. So let's go ahead and start solving. The problem that we'll be solving today is monthly percentage difference. Given a table of purchases by date, calculate the month-over-month percentage change in revenue. The output should include the year, month, date in this particular format and percentage change, rounded to the second decimal point and sorted from the beginning of the year to the end of the year. The percentage change column will be populated from the second month forward and can be calculated as this month's revenue minus last month's revenue divided by last month's revenue into 100. So they're also giving an idea on how to calculate this percentage change column. According to our approach, the first step is to understand the inputs and the outputs. And we can do that by reading the question clearly once again. Since they're saying given a table of purchases by date, calculate month over month percentage change in revenue, there is some date time column involved here. So for me to confirm whether we have a date time column or not, I need to have a closer look at all the columns in the table. So if I scroll down, I can see all the available columns in that particular table, which is named as the SF transaction. So I see ID, created at, value, purchase ID. So my input is going to be the date time column, which is created at. And since they are wanting the percentage change in the revenue, I'm guessing the value is the one which contains the revenue number. So my inputs are going to be created at, value. And they said the output should include the month, year, date, and percentage change. So my output are simply going to be that month, year column and also the percentage change column that we'll be calculating using the formula that they have mentioned in the question. So the second step of our approach is articulating our solution verbally to the interviewer, which is basically explaining our approach and getting a confirmation of our understanding. As specified in our question, the output should contain the date time column in a particular format, which is basically in the year and month. I'm going to use the date format function in MySQL, which will help me extract the year and also the month for that particular output column. And they are also asking us to calculate the percentage change in the revenue. Before we calculate the percentage change in the revenue, we first need to calculate the revenue, right? And for that, I'm going to use the sum for the entire value column and group it by the month and year column that we are extracting so that we can get the month-wise revenue. And this will generate the revenue for us. So once the revenue is generated, I'm going to now calculate the percentage change in the revenue using the formula described in the question. So in that question, they're using the terms such as previous month and current month. And one function that comes to my head for calculating the percentage change is the lag, which is a window function. And I'm going to use the lag for that. Now, they've also explicitly mentioned that they want us to round off the entire percentage change to 2 decimal points. And for that, I'm going to use the round function with the input as 2 so that the decimal points are rounded off at 2. And finally, they want us to order this as per the starting year. So I'm going to order it by the month, year column that we are generating. So this is basically going to be my approach. Now, the third step of our approach is constructing the query step by step. The first step of our query was extracting the month and the year from the datetime column using the date format function. So select date format from the created at column. It has to be in the format %y, %m. And I'm going to give this column a name as year month. And this data is coming from SF transactions. So I'm going to now run the query. As you can see on the screen, we have extracted the year and month column using the date format. Now, the second step is calculating the total revenue. So for that, I'm just going to check sum of value and give this a revenue name. And I'm going to group it by this column year month so that I get the monthly revenue. So I'm now going to run the query again. As you can see in the output, we now have the monthly revenue. Now our next step in constructing our query is calculating the percentage change in the revenue using the lag window function. And we are going to use the formula that has been described in the question. So as described in the question, I'm going to first use the formula this month's revenue minus last month's revenue, which is for this month's revenue, I'm simply just going to say sum of value. And for last month's revenue is where I'm going to use lag of sum of value. Okay. And since this is a window function to indicate the SQL that this is a window function, I'm going to use the over clause and I'm going to put this entire thing in brackets and divide this entire thing by last month's revenue again, which is where I'm going to use the lag sum of value. And I'm going to indicate that this is a window function, and I'm going to multiply this with 100. I'm going to give this column a name, percentage revenue. I'm going to run this. As you can see, the output now, we have the year, month, revenue, and percentage revenue. Now, this next step is rounding off this entire thing to 2 decimals. So I'm now going to use round function and then comma it by 2, and then going to run this code again. And you should be able to see that this is now rounded off into 2 decimals. Now, the last step that we need to do is basically ordering this by the year, month. I'm now just simply going to say order by year, month. And then I'm going to run. And you can see that again, this has been ordered. So this is our output. Since our question says that the output should only include the year, date, month, and the percentage change, I no longer need to show this revenue column. So I'm just simply going to remove this. You just simply have the year and the percentage revenue. So yeah, that's how you approach this particular SQL problem. Thank you so much for watching. I'll see you guys next time. Hello everyone. Welcome back to the series Solving SQL Interview Questions. In our last video, we've solved an SQL interview question asked at Google using our 3-step approach. In this video, we'll be solving an SQL interview question asked at Netflix. So let's go ahead and start solving. As shown on the screen, the problem that we'll be solving today is top percentile fraud on the same platform Stratus Crash that we'll be using throughout this series. Let's take a look at the question now. ABC Corp is a mid-sized insurer in the US, and in the recent past, the fraudulent claims have increased significantly for their personal auto insurance portfolio. They have developed a ML-based predictive model to identify propensity of fraudulent claims. Now, they assign highly experienced claim adjusters for top 5 percentile of claims identified by the model. Your objective is to identify the top 5 percentile of claims for each state. Your output should be policy number, state, claim cost, and fraud score. But before we get into that, I'm seeing terms such as percentile. So what exactly does this percentile mean? Percentile is simply a value under which a percentage of data falls into. So if you look at the screen, we have data points such as 40, 50, 60, so on. Total 10 data points, and we are being asked to calculate the 30th percentile. So the first step of calculating a percentile is arranging the data points in ascending order, that is from lowest to the highest. The next step of calculating that particular value under which 30% of the data falls is you have to count the numbers from left to right. 42 is the number under which 30% of the data falls into. Now coming back to our question where they asked us to identify the top 5 percentile, what they meant is basically finding all the values that fall under the top 5% of the fraudulent claims. The first step of our solution is identifying the inputs and the outputs. So let me take a look at all the columns that are present in the table to see which will give me the fraud claim. So I can see that there's a column called as fraud score. So I'm going to use this as the input for calculating the fraud claim. And since they're saying that they want it for each state, I'm going to use the column called as state as mentioned here. So my inputs are going to be fraud score and state. What are my outputs going to be? Here they explicitly mention that it should contain policy number, state, claim cost, and fraud score. Now the second step of our approach is articulating a solution verbally, which is basically explaining your approach to your interviewer and getting a confirmation. So in our question, since they're asking us to identify the top 5 percentile of claims from each state, the thing that comes to my head for calculating the percentile is a window function entile, which will help you calculate percentiles, quartiles, etc. So my input for the entile function is going to be 100 so that it divides the entire data into 100 equal parts, which is what percentile is. And then I'm going to use a filtering technique for filtering out the top 5 percentile. Now, when they said from each state, I'm using a window function here, right? And in window function, you have a clause called as partition by, which will help you create windows as per the column that you mention in it. And since the question says from each state, I'm going to say partition by each state in my window function, so that for each state, I'm going to get the top 5 percentile. Now, the third step of our approach is constructing the query step by step. I'm going to say select stars, since they want almost all the columns in the output. Entile is the function that I'm using to calculate the percentile with the input as 100, so that the data is divided into 100 equal parts. I'm going to use the over clause used to indicate that you're using a window function. And I want each of these windows to be partitioned by state, since the question states they want it from each state. And I'm going to order this by fraud score, the column which contains the fraudulent claims. And since they want top 5%, I'm going to order this by descending order. And I'm going to give this entire entile function column a name, which is percentile, since that's what we are calculating. And this entire data is coming from the fraud score table. So I'm running it. Okay, great. I now can see that it is ordered by the fraud score and divided into 100 equal parts. Now the next step is for me to filter out the top 5 percentile from this entire query. So this table has to be an input for another table so that I can filter it out using the where clause. So that's what I'm going to do now. This table is going to be 1, and I'm going to select star from this table. I'm going to give this table a name called as percentile table and filter out where percentile is less than or equal to 5, because we are looking for the top 5 percentile. So I'm going to run this query now. And there you go. You now have, as stated, it should contain policy number, state, claim, cost, fraud score, percentile, and then you're containing top 5 percentile for the each state. Since they said the output should only contain these and you don't want it to show the percentile, you can explicitly mention here what are the column names that you're looking for. So I can simply say policy num, state, claim, cost, comma, fraud score from this table, and then I'm going to run it. So there you go. Policy number, state. So these are the top 5 percentiles of fraud cases from each state. Yeah, that's how you go ahead and solve this particular kind of questions. I will see you guys next time. Bye. Let's take a look at the question now. Find IDs of companies that have more than 2 users who speak English, German, French, or Spanish. So according to our approach, our first step is to understand the inputs and the outputs clearly. Now, for me to understand the inputs clearly, I need to know what are the columns present in the table playbook users. If you scroll down, you will see the inputs that are given to you, which is user ID, created at, company ID, language, activated at, and state. Now, among these, what should be my inputs? And how will I know that? By reading the question clearly, which is find IDs of the companies. So I need to use the company ID that have more than 2 users. So when they're talking about users, which means I'll also have to use user ID, who speak English, German, French, and Spanish. So I don't see any columns with respect to this, but I can see that there is a column known as language. So I now need to filter out these languages from the column language. So what are my inputs? Company ID, user ID, and the language. Now, what are my outputs? Since the questions only simply states find the IDs of the companies, my output will only simply be company ID. So my inputs are company ID, user ID, language, and my output is only simply company ID. Now, the step 2 of our approach is explain your approach verbally. Now that you've understood what are the inputs and the outputs, you now have to explain to your interviewer what is the approach. If you look at the question, it says find the IDs of the company. So they want you to find for each company, which means you have to use a group by clause known as company ID. And then since they're talking about that have more than 2 users, they want to perform some aggregation function in this case, which is count. So you're going to have to perform an aggregation function count for finding out more than 2 users. And since they want it for each company, you'll have to do something called as group by for each company who speak XYZ languages. So you now need to filter out these languages from the column language. So one operator that comes to my mind as soon as I'm checking for a string value is in. So I'm going to check whether this particular language is present in the language column or not for that particular user. Now that I've explained my approach to my interviewer verbally, the third step is basically constructing my query step by step. And that's what I'm going to do now. The first step of constructing my query is filtering out the users who are speaking the languages X, Y, Z. Select, since my output should only contain company ID, I'm only going to give company ID from the table playbook users, where language in, I'm going to give English, German, French, and Spanish. So I'm just going to run this code. Okay, now it's showing me all the company IDs where these languages are present in. But since I want for each company ID, I'm going to do group by company ID. Great. Now the clause is they want the users who are more than 2 in number. This is where I'm going to use my having clause, having count of user ID greater than 2. And now a company might contain like multiple entries. I want distinct user ID, unique user ID. And I'm going to say, since this said it has to have more than 2, I'm saying greater than 2 and then executing my query. And it says there is some error which says having count. Oh, seems like I have a typo here. So I'm going to say distinct. And then I'm going to run my code. And there you go. So these are the companies where there are more than 2 users who speak the languages English, German, French, and Spanish. So this is how we approach in solving an SQL query. So keep 3 things in mind, which is basically understanding your inputs and outputs, explaining your approach verbally. Third thing is constructing your query step by step. That's it for this video, guys. I will see you next time. Bye.